In this video, I want to share with you my best videos on conic sections. I hand selected 45 videos through my whole back catalog to share with you on how to deal with graphing as well as writing a parabola, a circle, an ellipse, as well as a hyperbola. So we're going to go through some very basic examples as well as to ones that are more advanced, dealing with completing the square and labeling out of the parts. But I know if you work through this whole video, you are going to have an excellent understanding of how to graph and write your conic sections. I hope you enjoy. Now, ladies and gentlemen, I want to go through a process over here, and I'm going to kind of represent my process that I highlighted up on the board. So if you didn't write that down, I'd highly recommend, oops, wrong one. I'd highly recommend writing that down. It's just kind of a process, the process to go through. And that's what I'm basically going to do with you guys is identify the vertex. Now, before actually, there's kind of a step number one first. And well, it's not really a step, but it's a good way to see. You guys can see in red, I spent the time to write what type of equation I have next to it. Do you guys see how I did that? Because there's only two equations we've introduced. We've introduced a vertical parabola, and we introduced the equation for a horizontal, right? So you don't have to do this, but if you're struggling with what we're doing right now, I would highly recommend doing that. Because what we want to do to identify your h and your k and your p, we want to make sure it's in this format. Because if we have it in this format, then it's pretty easy to see what h, k, and p are, correct? Right? And actually, I gave you a problem. Question number 4 is already in that format. So number 4 is really easy to do, right? H, k, and p are right there. This problem, though, this doesn't look anything like that. Would you guys agree? This doesn't really look like this. So what we need to do is do a little math to transform the equation so it's in a format that we are familiar with. The first thing I would do is I would just rewrite the y squared. I'd flip it around. So therefore, I have the square term on the left-hand side. It doesn't have to be. You could have the square term on either side. But I just wanted to try to look like this equation as much as possible. The next thing I notice is this binomial here, squared, is by itself. It's isolated. There's no number that's being multiplied by it. However, the linear binomial has that 4p being multiplied, right? It has a number being multiplied by it. So what I'm going to do is I'm going to get rid of this 2 over 1. So I'm going to multiply by 2 on both sides. Then I obtain y squared equals 2x. Does everybody see what I have here? Now, it's starting to kind of look a little bit similar to this. Now, I don't have an h and a k. You can see I'm not subtracting anything. If you wanted to, bless you, you could rewrite it like this. You don't have to. But sometimes people, to understand it a little bit better, like it looking in that format. And I think looking in that format, it just kind of makes it easier to understand, oh, OK, h and k, which is the center, which is one of my questions, is 0, 0. Right? My 4p is equal to the number 2. Do you guys see? Whatever's being multiplied by your linear expression, 4p is being multiplied by your linear expression. So to find p, I do 4p is equal to 2. Then I just use some algebra. P equals 1/2. Now, to find the focus and the directrix, graphing it is actually a good idea. Because I think visually, graphing will help you. And this is what I'm saying. I didn't tell you guys step by step what to do. But I want you guys to kind of think about this. All right, well, I don't know what to do next, Mr. McLogan. So let me graph it and see what happens. The center's here. P is 1/2. Now, y is squared. So that means the graph opens left or right. But since p is positive, the graph opens up to the right. So there's my vertex. There's my focus. So if p is only 1/2 to the right, what is that coordinate point? 1/2, 0. And then the directrix is that same distance in the opposite direction. And it's a vertical line, which is x or y? X. X equals -1/2. Now I have answered the question on the quiz. And I got the 3 points. Welcome, ladies and gentlemen. So what I like to do is show you how to graph the equation of the parabola when I have x squared is equal to 30y. Since we know the x is squared, we can obviously see that, right? We can use the equation to be able to identify our vertex as well as the value of p by looking at our general form, which is x minus h squared is equal to 4p times y minus k. Okay, so by looking at this, what we can see is that our center is, what exactly is the center, right? Center is h comma k, where you can see we don't have any h and k's here, right? I'm not subtracting anything from the x and from the y. So therefore, our center is going to be at 0, 0, which is nice. And then the last thing we need to do really to graph this, we know x is squared, so therefore we know the graph is going to open up or open down. We just need to determine which one does it do. And you could probably look at the x squared and say, well, a is going back to some old quadratics and look at that and say, well, a is positive. But the way that we like to do it with our conic section is determine the value of p, because p represents the distance from the vertex to the focus. So 4p is equal to 30, right? You can see this is the same as that. So I write 4p equals 30, divide by 4, divide by 4. P equals 15 divided by 4, which is, 30 divided by 4, which is 15 over 2, which you could also say is like 7.5, right? Okay, so that means the focus is a positive 7.5 up from the center. 1, 2, 3, 4, 5, 6, 7, 8. Focus, all right? So since P was positive, I had to go up. And since the focus is going up, I know that my parabola has to open up, right? Because it always opens up towards the focus. Now to find the directrix is the exact same absolute distance from the center to the focus, but it's just in the opposite direction. So now I'm just going to go down 7.5. 1, 2, 3, 4, 5, 6, 7, 8. And then what's important about the directrix is, notice my axis symmetry is along the y-axis, right? It's vertical. The directrix is horizontal. It's perpendicular to your axis symmetry. So since it is a horizontal line, so here, let's write the focus. So the focus did not go left or right at all, so that's at 0, comma, I'm going to write 15 halves. I'm not going to write it as a decimal. And then my directrix is a horizontal line, which we can write as y equals 15 halves. So there you go, ladies and gentlemen. That is how you write the equation of a parabola, including the focus and the directrix. Thanks. So Nick, when I'm working on this problem, the main important thing that I like to do, guys, when I'm graphing parabolas, is I want to make sure, yes, did I write it wrong? So when I'm graphing this, the main important thing that I want to be looking at is determine, is this going to be a parabola that's going to open up or down, or is this going to be a parabola that's going to open left or right? We know that when we have x squared, a graph always opens up or down, right? So therefore, when we have a y squared, we know the graph is going to go open to the right or open to the left, correct? So this is going to be a horizontal graph, and there is actually an us to graph it. So the main important thing, though, is we still need to find the vertex, the axis of symmetry. All right. So the vertex, well, first of all, let's write out what is our standard form for a parabola that has a horizontal axis symmetry. That's x equals a times y minus k plus h. So to find our vertex, remember the vertex of a graph is still h comma k. So in this example, it's going to be -3 comma -1. Right? Because remember, it's always opposite of h. Yes? Yeah. So now we need to find our axis of symmetry. Now remember, the axis of symmetry is now horizontal, yes? Huh? Oh, right there? I did spell symmetry wrong. Thank you. So, thank you. It's been a rough morning so far. So we have axis symmetry. Now we know that this is a horizontal graph, so we're going to have a horizontal axis symmetry, right? So therefore, remember, our axis symmetry always has to go through our vertex. Alex, it always has to go through our vertex, OK? So since it's always going to be going into our vertex, what I'm simply going to do is now say, all right, so what coordinate is going to be related to, my h or my k? Your k, all right? And then, since it's horizontal, it's going to be y equals k. So in this example, it's going to be y equals -1. So let's go and plot this so far, just to go and see what we exactly have. So right now, I have a graph. It's going over -3 down 1. 1, 2, 3, down 1. That's my vertex. It has an axis of symmetry at y equals -1. All right? Now what we need to do is determine the opening. So we look at our a, which is 3, which is greater than 0. So when we have an opening that's positive for a horizontal parabola, does it open to the right or to the left? To the right. So now my graph, I know my graph opens to the right. Yes? Yes? OK, very good. So now let's just go ahead and there's a couple ways we guys can do this. We could easily graph the rest of this just by plotting, using a table. But I'm going to help you guys use this. But we're going to sketch the graph by using the focus, directrix, and the lattice rectum. All right? So the focus in this example, if you guys remember, is going to be your focus is now, since my parabola opened up to the right, my focus is now going to be moved to the right. So therefore, I need to now determine what my focus is going to be. So remember, the focus is going to be h plus 1 over 4a comma k. Notice how this is different than the vertical one. All right? This is different than the vertical one, right? Because now we're moving it left or right, so it's going to be plus 1 over 4a. So now I look at this and I say, well, 1 over 4a, that's going to equal 1 over 12, right? So my h is going to be -3 plus 1/12, which is going to be, let's see, 36. So that would be 33 over 33 comma h, which is -1. So that's not only moving, you're only really moving over you're only moving 1/12 in. So this is going to be very close of a foci. And your directrix is now going to be is going to be the same thing, but now it's going to be y equals h minus 1 over 4a, which would be minus 4a, which is going to be equal 1 over 4a is -1/12. So therefore, minus 1/12. So you're going to have -3 minus 1/12. So that would be -30. So it'd be -39 over 12. So that's your directrix. Then we can determine the lattice rectum. And remember, the lattice rectum is going to be absolute value of 1 over a. Well, 1 over a is 1/3. So therefore, our distance of our lattice rectum is really, if this is down -1, it's like 1/6 of the way. So you're going to have a very skinny parabola. All right? Now, we can verify these points. All right? I'm not going to ask you, for this type of problem, I'm not going to ask you to verify them. But what I can simply do is, if you guys wanted to test a point, we can easily just plug in a value for y, or plug in a value in for y, and see what the x value is going to give us. Right? If I plug in my value for y, I could see what my x coordinate be. So if I plugged in, let's do when is y equals 0. So if I do 0 plus 1 is 1 squared. So when y equals 0, x equals 0, right? Yeah. So you can see that that is going to be a coordinate. Right? So therefore, the graph has to go through y equals 0 over 0. And that's just going to kind of give you your sketch of the graph. And that's all I'm really asking you guys to do is just sketch the graph. To make some more coordinate exact points, we could plug in more points. We could plug in 1. 1 plus 2 is 4. Or I'm sorry, 1 plus 1 is 2. 2 squared is 4. 4 times 3 is 12. 12 minus 3 is 9. So at x equals 1, we're going all the way over to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes? 0, comma 0. And then, or this is 9, comma 1. Yes? And then you can use the reflection, the axis symmetry, to reflect over to your other 2 points. OK? All right, so ladies and gentlemen, the main important thing that I want to look at when doing a problem like this is we have x squared plus 6y equals 0. All right? So last class period, we talked about kind of more with the definition of a parabola. But now what we're going to be doing is, kind of using this because they're asking us to find the directrix, the focus, and the vertex of the parabola, right? OK. So the first thing we need to understand is, first of all, is this going to be a parabola? It's going to have a vertical axis symmetry or a horizontal axis symmetry. Restating, is it going to go open up or down, or is it going to open left or right? So we look at what variable is being squared. And in this case, we have x being squared, number 15. So since this is x being squared, is the graph going to go open up or down, or left or right? Up and down, right? And what you guys are familiar with. When you guys see x squared, you know it's going to be a parabola. That's a function that you're familiar with. So to go back through this, we write down the formula that we've discussed with deals with the vertex. So we have x minus h squared equals 4p y minus k. Right? That was our definition. That was our formula for the definition of parabola, which details the value of p, which is going to be your distance from your vertex to your focus. All right. So they're asking us to find the focus and the directrix and the vertex. Well, first of all, remember the vertex is h comma k, right? That goes back from your other form. So we know vertex is h comma k. Well, let's look in this format. First of all, it's not even in that same format, is it? Right? So first of all, let's subtract the 6y on both sides. So I have x squared equals a negative 6y. All right. So now we look at this, ladies and gentlemen. We see, do we have a vertex at all? Am I subtracting anything from the x or the y? No, right? So therefore, we can say the vertex in this problem is going to be 0, comma 0. Right? Because there's no x minus anything squared or y minus anything squared. Right? Does that make sense? OK. So now to find the focus and the directrix, we need to make sure we understand the value of p. So in looking in this formula, first of all, when we're looking at this formula, we know that negative 6 is equal to 4p, right? Because 4p is what you multiply by y minus k. Well, it's y minus 0 in this case. So we can say that negative 6 is equal to 4p. Now, divide each side by 4, and we say p equals a negative 3/2. Now, since we have a p-value that's going to be negative, remember the p-value is going to be the distance from our vertex to our focus. So since it's negative, that means we're going down. So if we have a parabola with the vertex, and then the focus is below it, is the graph going to open down, or is it going to open up?
Down.
It's going to open down, right? Very good. So we can say p is going to be negative 3/2. And remember to find the focus. That's going to be h comma k plus p. So in this case, our focus is 0, comma 0 plus a negative 3/2, which is 0, comma negative 3/2. Right? So to find the focus, remember we do k plus p. When it's a vertical, you're adding it to your k value when it's vertical. Now, to go and find the directrix, remember, ladies and gentlemen, the directrix is a horizontal line when you have a vertical parabola, and it's opposite of the focus, right? The distance from the vertex, or for any point on the parabola, the distance to the focus to the directrix is exactly the same. So to find my focus, if I'm going to add p, to find the directrix, I subtract p. But remember, the directrix is a line, not a coordinate point. And it's a horizontal line, right? So it's going to be k minus p. So y equals 0 minus a negative 3/2. Y equals 3/2. Now let's just do a quick little sketch. So you have your parabola. We know the vertex is at 0, 0. Right? We know now the focus is at 0, negative 3/2. Right there. And we know the directrix is at 3/2. And the parabola opens down. Cool? Amazing? Does that make sense? Kind of? The main important thing, guys, when we're trying to find this focus and directrix is we have to know this value of p. That's what's so important that we're dealing with now, is that value of p. So, in this problem, the main important thing, guys, let's just go through my steps that I've been talking about. The first thing is to determine what type of parabola are we dealing with. Are we dealing with a vertical or a horizontal? And we look at it and we say, all right, again, we have an x squared, so we're going to be dealing with a vertical parabola. Again, I'm going to write that down so I do not forget it. Because when we're changing things, when we're finding the focus, the directrix, it's gonna matter if we're dealing with a vertical or horizontal. The next thing is I need to write it in standard form. So I take a look at this, x squared plus 4x plus 6y minus 2 equals 0. Does that look anything like our standard form that we've been talking about? Right? Well, no, it doesn't look anything like it, does it? The one thing I know that's on the left is the x squared, and that's it. So what I'm going to do is I'm going to subtract the 2y and the positive 2. So I have x squared plus 4x equals negative 6y plus 2. Now, I kept the x on the same side is because we've never dealt with having a linear term with our parabola here, right? But the one thing I remember is when we have something like this, if I want to get it to this format, what I can do is complete the square. And remember, the completing the square kind of goes back to our quadratic form, is that when we have a b, or the coefficient of our linear term, we can take that, divide it by 2, and square it, and then we add that to both sides. So let's go and complete the square for this. So what I'll do is I'll take 4 divided by 2 and square it. Well, 4 divided by 2 is 2. Square is going to be 4. So what I have is x squared plus 4x. I'm just going to write down again what to do with the b divided by 2 squared. You add that to both sides.
What?
Yes.
When you do complete the square, what you do is you do b divided by 2 and square it, where b is your 4. Okay, I'm just showing you guys what.
But why is it there? I don't
Why are we doing that?
Yeah.
Let's write it in and I'll show you. So now we determined that b divided by 2 was 4 divided by 2 squared. So that gives me x squared plus 4x plus 4, right? B divided by 2 squared equals 4. Equals negative 6y plus 2 plus 4. Okay? I had to make sure I added on both sides because we had an equation. And that's one of the first things you learn by equations. Whatever you do on one side, you have to do on the other.
Just randomly do that. So if I wanted to put a 3 on there, just add a 3 to both sides, and we have a 3. What?
It's an equation. You can do that, but there's a reason why I did this. There's a reason why I did b divided by 2 squared. Because what had happened by doing that, I now gave myself a perfect square trinomial that I can rewrite now as a binomial. And that's what I want. Guys, I want it to look like this. X, minus h squared. I want it to look like this. So then what I did by completing the square, what that gave us is a perfect square trinomial that I can now write
X plus 2
as I can write it now as x plus 2 squared. And let's check that work. Does that work again? X plus 2 squared is x plus 2 times x plus 2. X times x squared, 2 times x is 2x, x times 2 plus 2x, 2 times 2, 4. Okay? That's why we complete the square, so we can get it to that format. Yes?
So we don't have to change it to a minus? Does it say x minus 8?
I mean, you could write it, if you want to change it like to a minus, you write it like this. X
Okay,
minus is positive 2. It's still, I'm sorry, that's a negative. So it'd be x minus a negative 2, which would still be a plus. If you want to write it as a subtraction, you could write it as a subtracted negative number. All right? She was just asking, you know, why can't you write it as a negative? Well, you could. You could write x minus a negative 2, which would give you the same thing. Got it there?
Yeah.
Okay, so these are just practice with completing the square. Then I look over here and I say, all right, how can I rewrite this? Well, I have a negative 6y, 2 plus 4 is plus 6. Now, we can factor that out. Equals, I'll factor out a negative, actually let's factor out, a negative 6. No, let's factor out a,
Negative 6. Yeah.
negative 6.
yeah, let's factor out a negative 6. Okay?
It can be both ways. Positive or negative.
Because let's take a look at it. So now we have it in this format, but is it still exactly in this format yet? No, I don't have it multiplied by 4 yet, right? So now I need to figure out, I can say 4p equals negative 6. Right? It's almost in that form, right? We got an x plus 2 squared equals negative 6y minus 1, but we don't have that multiplied by 4 to figure out what our p-value is. So I say 4p equals negative 6.
Negative 3 over 3.
So you divide by 4. P equals negative 3 divided by 2. So now, so I can write 4 times a negative 3 divided by 2 times y minus 1. Okay? Whew! So I did all of this work, right?
This is ridiculous.
It's a ridiculous.
So what?
Use the quadratic formula.
For what?
I don't know.
Just to say you got it. You want to use the quadratic form if you wanted to find the intercepts. But right now, if we want to find the intercepts, then yeah, we'd use the quadratic formula. But we're not trying to find the intercepts. We're trying to find this point, and this point. All right? Now, we know it's a vertical. Now, I wrote a parabola opening upwards, but let's go ahead and take a look at it and see actually where our parabola is.
We're at a question.
Yes.
So if it's horizontal, it'll open down.
No, if it was horizontal, it would open left or right. We'll do a
So
problem
we'll
like that.
turn this way.
It'll be like this.
Yeah.
Sorry.
So let's take a look at it. Here, now let's just write in the information. So the vertex, negative 2, positive 1. Right? Remember, we're going to take the opposite of our h and k as our vertex is h comma k. Yes, Mike?
Should we write it like the equation way at the top? The bottom equation, should we write it like, because it's x plus 2 at the bottom, should we put x minus 2?
You don't have to. You could write it like that.
I just like the opposite. Yeah, so is it
You do. That's what I'm saying. You can leave it like that and just know that your vertex is going to be the opposite.
I know I'm saying, but you put a negative 1.
Oh, you're right. Thank you. My bad. Thank you. Opposite of negative 2, comma, positive 1. All right? Then the next thing is we determine our p, which is a negative 3/2. So now we need to figure out the focus. Remember, the focus is h, comma, k plus p. Right? So we look at this, and that is, what do we got?
Negative 2.
So we have negative 2, comma, 1 plus a negative 3/2, which would be negative 1/2, right? When you combine those two terms. So therefore my focus is negative 2, negative 1/2. Get be the same denominator?
But just 1.5 minus 1.5.
Okay. Huh? So then when I'm looking at my directrix, all right, so let's figure out the directrix
Okay, mine.
is going to be -2, comma, now 1 minus a -3/2, which is going to be plus, right? Double negative makes us plus. I'm sorry.
Yeah, you
All
can do
right.
that.
Sorry. Y equals your. Let me write out the formula. If you don't write out the formula, you're bound to make mistakes. Your directrix is going to be y equals k minus your p. Okay? So therefore, y equals your k, which is 1, minus a -3/2. All right? Please write out the formulas, unlike I tried to do. Sorry? Yes?
No, nothing.
Okay. So now, double negative is going to be add, right? So that's going to give me 5/2, right? So now let's go and take a look at our graph, and let's just do a little sketch. I'm not going to get crazy with it. If we're going to make a graph here, all right? If we make a graph, the first thing we go is to our vertex. -2 up 1. It's right there. Then it says my P, first of all, without even knowing what the point is, you can rewrite the focus, but my P tells me to go down -3/2, right? So that means I have to go down -3/2. So is my parabola going to go open up or open down?
Down.
It has to open down because the focus is inside your parabola. All right?
So technically, whatever P is, that's what you can figure out if it opens up or down.
Yes, because if P is positive,
It opens up.
then you're going to open up. And then I look at my directrix, which is 5/2, which is going to be 2.5.
Which one is that?
Your directrix, which was 5/2. Which would be 2.5. Okay, you got that?
This is pretty easy.
So, first things first. What is mean squared? X or y? Y. So that means the graph opens up or down or left or right? Left or right, right? So the main important thing now is to say, all right, since y is mean squared, let's use our formula for the definition of our parabola when our y is squared. So we say y squared minus k equals 4p x minus h. All right? I did find my formula sheet, so you guys won't have to worry about all this stuff. But you guys need to get these formulas. Understand, right? Okay. So now, we need to make this look like that. Because once we know that once this looks like that, is it pretty easy to find the vertex, directrix, and the focus? Yeah, the vertex is there, then you know P, then you can find focus, directrix, so it's easy.
Maybe outside of the Y.
Yes, it is. I don't know what else. Thank you. Okay, so to make this look like this, let's get the x's on the other side, right? And this, let's get the exit over here. So I have y squared plus 6y equals minus 8x minus 25. All right? Now, this looks kind of like there, but you can see that this is a binomial squared, right? And this is not a binomial squared. So you could factor out a y, but that's not going to make it look like that. So to make this a binomial squared, we have to complete the square, right? So if you guys remember completing the square, you take your b, 6, divided by 2, square it, which equals 9. Then we add 9 on both sides. Y squared plus 6y, and I'll even use a little color, plus 9 equals negative 8x minus 25 plus 9. And why do we complete the square? The reason why we want to complete the square is because when we take b divided by 2 and square it, we now have just created a perfect square trinomial. And why is perfect square trinomial so nice? Because perfect square trinomials can be factored to a binomial square. And in this case, we can rewrite this as y plus 3 squared. Then we just do a little simple math over here. Negative 25 plus 9 is going to give me a negative 16. Right? And now I can factor out a negative 8. Now, does it look like it's in our formula? Yeah, absolutely. So do you guys see how just completing the square is just going to help us apply that? So if you don't have it as a binomial square, you're going to have to use the process of completing the square. All right, so now let's just go through it. So the vertex we know is hk. Remember, it's opposite of k, opposite of h. And then also, ladies and gentlemen, remember that here's the k and here's the h. Right? A lot of students, because they know that for vertical parabolas, it was h and k. Right? So they say, oh, the vertex is going to be negative 3, negative 2. Be careful. Here's your h, and so your vertex in this case is negative 2, negative 3. Now, what does our 4p equal? 4p equals negative 8. So we say negative 8 equals 4p, divide by 4, divide by 4, p equals negative 2. So now we know p is negative 2. Does that mean, since my graph opens right or left, when my p is to the left, that means my graph is now going to open. Or I'm sorry, p is negative, so that means my graph is not going to open to the left, right? So again, to find the focus, since we're shifting left and right, we're not going up and down, remember we're going to be adding points to the, remember vertex, or is h comma k. So the focus is going to be h plus p comma k. Notice how that's different than what it was for the vertical parabola. The vertical parabola, it was plus k. Now it's going to be plus h because h is your x coordinate. So we look at this and we say negative 2 plus negative 2 comma negative 3. So we get negative 4 comma negative 3. Then the directrix. Remember, ladies and gentlemen, my directrix is a vertical line. So instead of y equals, on our last problem, now it's going to be x equals. And it's just going to be x equals h minus p. So x equals negative 2 minus a negative 2, which now it turns into a double negative. So x equals 0. So let's take a look at the graph. So we have our vertex, which is at negative 2, negative 3, 1, 2, 3. We have our focus is at negative 4, 1, 2, 3, 4, negative 3. Here's the vertex, here's the focus, and then our directrix is at x equals 0. There you go. Cool? Welcome, ladies and gentlemen. What I'd like to do is show you how to write the equation of the ellipse given the focus and the vertex. So the first thing we want to do is identify, where is the axis symmetry? Is that horizontal or vertical? Where does the graph open up? Left or right, up or down? So first thing we need to do is just identify where the graph is going to be looking. So we know the vertex is at 0, 0, and the focus is at 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. So therefore, we can see that, remember, if that's the focus, that's the vertex, my graph has to open up, right? So therefore, the standard form that I'm going to use is x minus h squared equals 4p times y minus k. This is the standard form for any time you have a vertical axis of symmetry, or in other terms, your graph opens up or down. So remember, the vertex is represented by our coordinates h comma k, which in this case is 0, 0. And also remember that the distance from your vertex to your focus is p. In that case, it is 8. So now let's plug in our information. So I have x minus 0 squared equals 4 times 8 times y minus 0. Simplifying this, I have x squared equals 32 times y. So now, just to go ahead and solve for y here, I can write y equals, So to solve for my y, I'll just divide by 32, divide by 32. And I get y equals x squared over 32. You could also write it as y equals 1 32nd times x squared. So there you go, ladies and gentlemen. That is how you write the equation of a parabola given the focus and the vertex. Thanks. We've talked about two different formulas, right? We talked about a formula when we have a vertical parabola, either opens up or opens down. But then we also introduced a formula for horizontally, right? OK. So right now they're saying find the standard form of the equation if we have a vertex at 2, 1 and a focus at 2, 4. So right now I need to determine, well, which formula am I going to be using with the focus? Am I going to use the vertical and the horizontal? So the best thing I would tell you guys to do first is to plot the points and see which one would make sense. So let's plot the 2 points here. So if I have a vertex at 2, 1, and then I have a focus at 2, 4. 1, 2, 3, 4. Now remember, the definition of a parabola is the set of points that are equidistant from a focus and your directrix. So remember, our directrix has to be the opposite direction from our focus. So if our focus is up, our direction, so this distance is 1, 2, 3, 1, 2, 3, 4. That's right there. So there's our focus. And then this one's going to be up 3. So now 1, 2, 3. So we don't really have to write our directrix. But now you guys can see here's our directrix. Here's our focus. What way is the parabola going to do? Is it going to open up, down, left, right? Which way is our parabola going to open up? Anybody? Bueller? Yeah, but which way? Is it going to open up? Is it going to open down? Left, right? Up, right? Because it always is going to open so it contains your focus. Because remember, these distances, and I know my parabola is not the best, but you remember the distance from the focus to the directrix has to be equal for your parabola. So your parabola is always going to contain inside of it its focus.
Is it always going to have the same number, like on this one, how the x's are going equal to?
Remember, when it's a vertical, right? When you have a vertical, it means it opens up or opens down. Yes, your focus and your vertex are going to have the same x coordinate. And if it was horizontal, they'd have the same y coordinate. So now we know we're dealing with a parabola that's going to be vertical, so we can write the equation. So we have x minus h squared equals 4p times times y minus k. All right. So they said find the standard form. So we know that we have our vertex, which is our h and our k, so we can plug that in. All right. So that was our h and our k. That's from what we've done before. But now we need to look at what is our p. Remember, the p is your distance from your vertex to your focus, and it's also the distance from your vertex to your directrix. But we're just going to be looking primarily and seeing what is this absolute value. Obviously, it's positive to the focus and negative to the directrix, but the absolute value of that is going to be 3. Well, I'm sorry. Your p, we're just going to be looking at the positive value. Since this opens up, we're going to want to make sure it's positive. So we notice that this is going to be 3, because obviously, if our vertex opened down, this p would be negative, right? So we're just going to look at from this distance when it's going from your vertex to your focus, which will be 3. So we'd have x minus 2 squared equals 4 times 3 y minus 1. All right? So this is going back to our standard form, but could we write this back into a standard equation, standard form that we've done before? Yeah. So we have like this. So now you could just do x minus 4x plus 4 equals 12, y minus 12. Yes, it is. All right. Then what you could do is you could add the 12 to the other side. So you have x squared minus 4x plus 16 equals 12y. Then you want to get the y by itself, right? So we divide by 12. And rather than having each one of these terms divided by 12, we could just say it's going to be y equals 1/12 times x squared minus 4x plus 16. Or you could have every term, simplified every term by dividing by 12 and leave them as fractions. So you'd have 1/12 x squared minus 1/3 x plus 4/4. You could do it that way as well. And for a conic section, or doing anything for conic sections. And again, we're going to be doing this parabolas, but what I teach today, we're going to do the exact same first step. Is the most important step for you guys to do. And that step is to plot the information that you're given. We're not graphing it, but you need to plot it so you can understand which formula you are going to be using. So we have a vertex at 0, 0. Vertex. Y equals 4. What does that produce? Well, if here's my y-axis, 1, 2, 3, 4, that's going to produce a horizontal line at y equals 4. Does everybody follow me? So now, we know that we have our vertex. We know we have a directrix. Does our parabola open up towards its directrix? No. So we know the graph is going to be opening down. Right? It doesn't open to the right, doesn't open to the left, right? So therefore, we now know which variable should be squared. X should be squared, and we also should know what should be our value of p, which is going to be the distance from our vertex to our focus, is going to be negative, though, right? So it's going to be negative. We want to make sure because we're going down. Yes. Because you can see the parabola doesn't open up towards the directrix. It opens away from the directrix.
Oh, you're right.
Right? I mean, you can see here's the directrix, here's the parabola, right? So the formula that I'm going to use to write my equation is going to be x minus h squared equals 4p times y minus k. Now again, we know that the distance from the vertex to the directrix is p, which is equal to 4 in this case. However, the real value of p is actually the distance from the vertex to the focus, which is still going to be the same value of 4, but it's going to be in the negative direction. So we could say that's our focus. And all they're asking for is write the equation, right? So I know my h and k, my vertex, is at 0, 0. Once you guys get good at this, you don't need to write in 0, 0. But just for right now, I'm just going to do that. So does everybody see what I inputted in? I inputted 0 for h and k. And then I inputted -4 in for my value p. Because value p is the distance from your vertex to your focus. OK? Always use that value for your p. Even though the absolute distance is 4, but since we're going down, so it's going to be negative for that. Does that make sense? So then my final equation would be x squared equals -16y. Done. So when doing a problem like this, you're going to plot the information. First thing is we plot the focus, which is at 1, 1, 2, 3. Directrix is at -3. OK. So first of all, we know that if the directrix is vertical, that means my parabola should open up or down or left or right? If my directrix is vertical, that means my parabola should open up left or down, left or right, or up or down? Left or right, right? You guys see? Vertical directrix, parabola opens up sideways, right? So now I just need to figure out where should it open up. Well, does my parabola open up towards my directrix or away from my directrix? Away from it. So I know the graph opens up to the right. My problem is I don't know what my vertex is. You gotta keep on going back to this. Yeah. So if you guys remember, if you guys look at your thing, the distance from your vertex to your focus is p. The vertex to your directrix is opposite of p. So that's what we call the focal length. It's very important for you to hear that, Natalie. The focal length is the distance from your vertex to your, from your directrix to your, the directrix to your focus is what we call our focal length, which is 2p. So my vertex is halfway in between. So this distance is 1, 2, 3, 4. So therefore, I could say my vertex is right there. Halfway in between Because vertex of focus is P, vertex of directrix is opposite of P. You guys see that? Now, all you got to do is figure out my values. So I know this is a sideways parabola, so I'm going to use this formula. Right? Sideways parabola. Then my vertex, my h and my k, this is -1, 3. So that's my h and that's my k. And then my p is the distance from my vertex to my focus, which is 2, and it's going to the right, so it's positive. So I have y minus 3 squared equals 4 times 2 times x minus -1. And then we just go ahead and simplify. What I want to do with you is just kind of go over. I'm just going to give you one general form of an equation. An equation for an ellipse, a hyperbola, a parabola. Actually, you know what? I'm just going to give you I'll give you the general form of an equation of a ellipse, hyperbola, circle, and a parabola. All right, and then that will help us kind of determine what we're going to be looking at. So let's look at an ellipse. Ellipse, if you guys remember, x minus h squared plus y minus k squared. And let's just do b squared over a squared. All right, this would be a, and that equals 1. This would we know that is going to be an ellipse with a vertical major axis of symmetry. Here's an equation of a hyperbola. And let's do x minus h squared minus y minus k squared over a squared over b squared. In this case, we have a hyperbola. Now, since my x is over my a, this would be one where we have a transverse axis is horizontal. Let's do the equation of a circle. Circle would be x minus h squared plus y minus k squared equals r squared. Okay. And then let's look at a parabola. And let's just do x squared, or keep the center, x minus h squared equals 4p y minus k. Right? So those are kind of your general forms. We know that there's two different forms of an ellipse, one with a major axis that's horizontal and one a major axis that's vertical. Right? To change that, we'd swap the x and the y's up here. We know a hyperbola, we can have a transverse axis that's vertical or that's horizontal or vertical. And we do that again by changing the x and y's over here. However, for circle, we're only going to have one equation because a circle has the same major axis of symmetry, or same major and minor axis. They're equal lengths. And a parabola, we would have the x's and the y's could be switched depending if we're going to have a parabola that's going to open up or down or left or right. Now, so I didn't write down all the equations because we don't need to. What I want to do is to kind of discuss one thing and then look at that, how that relates to a general form. So what I have here is I have 4 examples of conic sections that are written in a general form. And what we need to do is by looking at that equation, we need to determine, is it an ellipse, hyperbola, circle, or parabola? All right? So if we look at this general equations, what we did is I gave some coefficients, a, c, d, e, and f. All right? And what we're going to do, and actually let me change this to a b, just to maybe kind of make this a little bit less confusing, even though I know previously we've done a c. But let's just focus on our a and our b coefficients. All right? So no matter what equation we're going to look at what are the coefficients of our x and our y squareds. Okay? Does everybody see what I did? I want to focus on our a and our b. Now, let's look at what would a and b, even though they're lowercase here, what would our a and b be our case? Well, guys, dividing by x minus h divided by b squared, is that the same thing as multiplying by 1 over b squared times x minus h squared? Is that the same thing? Instead of dividing by, is the same thing as like multiplying by 1 over b squared? Is that the same thing? Yeah, OK. So what I want to do is I want to look at this. And if I take since I'm taking this time plus this, that means my A and my B are going to have to be, if they're both positive, since it's like in this problem, this is an addition problem, right? So that means that my B is positive and my A is positive, right? Because if I made this a negative, well, then the problem would be subtracting. So if these are both positive, the multiplication, the product of those two values has to be larger or greater than 0. If I take two positive numbers and I multiply them, does that have to be larger or smaller than 0? Larger, yeah. So for an ellipse, what I can do is if I say my A times B is greater than 0, then it is an ellipse. All right, let's look at a hyperbola. See, on a hyperbola, my B squared is always negative. It's always going to be negative. If it's not negative, then it's not a hyperbola. It could be an ellipse, right? But if I have A minus B, that means A is positive and B is negative, right? So if you can write something as a hyperbola, one of them is negative. So if you do A times B, and if one of them is negative, does it have to be less than 0? Yes. Yeah. So a hyperbola is A times C when it's less than 0. All right. Now, let's look at a circle. If we were to divide our circle, let's say, oops, this equals 1. Let's say we wanted this to equal 1. So we divide by r squared. Therefore, then this would now equal 1. Now, I know I don't have A and B in here, but let's replace our r squared with an A and our B. Is our A and our B the same value? Are our two denominators the same value? They're both r squareds, right? So therefore, in this case, A and B are not separate, but we could say A is equal to B. So if A is equal to B, then you have a circle. And then a parabola is very helpful, because when we look at a parabola, we only have one x squared, right? We don't even have another x squared. We don't even have a y squared. We're only provided with one square value, right? So therefore, you could say when A times C equals 0, or A times B. Because therefore, if I don't have an x squared or a y squared, then that coefficient has to be 0. So let's go and take a look at our problems and see if we can determine which one is a parabola, which one's an ellipse, which one's a hyperbola, and which one is a circle. So let's look at the first two. Again, all I did was I took these coefficients of my x squared and my y squared, and let's multiply them. So 6 times 6 equals 36. So what do we have for 30? Well, anyways, sorry. So we know that's greater than 0, but we know that 6 is equal to 6, right? So what happens when we have our two coefficients are equal to each other? That is now a circle. So we can say this one is a circle. Here, I do 6 times 9. 6 times 9 we know is greater than 0. So therefore, it has to be an ellipse. Here, I do 4 times negative 12, which is equal to negative 48, which is less than 0. So therefore, this is a hyperbola. And then over here, I have 1 times, I don't have a y squared, do I? So it's 0, which equals 0. So therefore, this has to be a parabola. You got that, Olivia? OK. So there you go. Does that make sense? A little bit better sense? OK. So here's a standard formula for our conic sections. And our conic sections have included a parabola, a circle, an ellipse, and a hyperbola. Now, I'm not going to go through every single formula for these, but let's just kind of go back and review how we wrote some of the equations for these. So a parabola, the equation that we used, and I'm just going to give one. I know there's horizontal and vertical for all of these, but I can just say y minus k squared equals, what was that, x minus h? It was 4p. Right? That was just a general equation for a parabola using our conic sections. For a circle, we can say x squared plus y squared equals r squared. All right? for an ellipse, I'll just do horizontal for ellipse and hyperbola. So I can do x minus h. Oh, really, I could do x minus h, but we'll use that. Actually, let's do it that way. There you go. So x minus h over a squared plus y minus k squared over b squared equals 1. For a hyperbola, a vertical hyperbola, it would be x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, so that's just an example. I'm just writing down one example of a parabola, one example of an ellipse, and a hyperbola. All right, now, so what I'm going to do for these types of problems is I'm going to give you an equation that's going to be in this format. And I'm going to ask you to determine, is this a parabola, a circle, an ellipse, or a hyperbola? So to do that, there's actually some very basic rules. All right? And all you're going to be looking at is your a and your b. So what I look at in here is if I was obviously to expand this, y would be squared, correct? Is x ever going to be squared? No, because a parabola, you only have one term that's squared, right? So if you have something that was in this format, a or b would have to be 0, right? Because you can only have one squared number. Does that kind of make sense? If I was going to give you an equation, a or b would be 0. So to determine if it's a parabola, a times b is going to equal 0. Because one of those terms, a or b, it doesn't matter. You're either going to have x squared for a parabola or you're going to have y squared. We don't have both squareds for parabolas. OK? Thank you, Hunter, for passing that along. So when you're either going to have one of those two are going to be squared. The easiest way to look at it is just what's your squared term, either an x squared or a y squared? There you go. All right. Now let's go and look at a circle. Now remember, a circle actually is an ellipse, right? But it's a special type of ellipse where if we were going to set this equal to 1, I would divide by r squared, divide by r squared. And what we notice is the denominators for these are exactly the same. A is equal to b, right? Those two terms, like it has an ellipse, a is equal to b. So to determine if you have a circle, a is going to be equal to b. So if I give you an equation that's in this format, to determine if it's a circle, you just need to look at the coefficients of x squared and y squared. If they're exactly the same, then your a is going to equal your b. All right. The next one is an ellipse. Now, what's nice about ellipse is you notice that ellipse always has the positive, right? It's always addition. So a and b are always going to be positive, always, for an ellipse. Yes, Amelia. Thank you. So a and b are always going to be positive. So if I give you an equation in this format, all I need to do is look at a and b. If a and b are both positive, or their product is greater than 0, then I know it's an ellipse. All right. And then lastly, guys, for a hyperbola, you notice the difference between a hyperbola and an ellipse, Joseph, is that I have the subtraction sign. That means my b squared is always that negative, right? Or this term is always going to be subtracted. So there, to determine if it's a hyperbola, a times b is going to be less than 0, meaning that one of these terms, your coefficient of x squared or your coefficient of y squared, one of them has to be negative. And if you can determine that one of them is negative, their product is going to be less than 0. Therefore, you have a hyperbola. So overall, all you're going to have to do is, when provided an equation in this format, is check your coefficients for your x squared and check your coefficients for y squared. And then apply these rules. By applying these rules, you can determine if it's a parabola, circle, ellipse, or hyperbola. OK? So on this example, what they're asking us to do is sketch the graph. So I have 3x squared plus 3y squared equals 12. Now, ladies and gentlemen, remember, when we're graphing, we can write the standard form of a circle as x minus y, x minus h squared plus y minus k squared equals r squared. All right? Now, in this case, we don't have x or y minus anything, right? So therefore, we can say that our h comma k, which is our center, is at 0 comma 0. Would everybody agree? We're not subtracting anything from the x or from the y. So we can say the center is 0, 0, right? Our r squared gets a little troublesome, though, because when you look at r squared, we're having 12. But that's only when we're looking at that, when we don't have when we just have our x and our y's, right? Our x and our y's here, they're not being multiplied by any number, are they? Right? In our standard form of the equation, they're not being multiplied by every number. So if we can get our x and our y's by themselves, then that equals your r squared. That's going to take care of like your dilation of any sort. So what I need to do is I need to get rid of these 3's. So how can I get rid of it? If I'm multiplying by 3x squared plus 3y squared equals 12, how can I get rid of being multiplied by 3 for both of these? I can now divide by 3. So that's exactly what I'm going to do. I'll divide by 3 on both sides. Well, 3 divided by 3x, that divides to 1. 3 divided by 3y, that divides by 1. So therefore, I'm left with x squared plus 3x squared equals y squared equals 12 divided by 3, which is 4. Now we can say that r squared equals 4. So therefore, our radius equals 2. So to graph this, we know that the center is at 0, 0, and our radius is 2. So we know that the distance from every point from our radius is going to be at 2. So it looks something like that. So you got to make sure, ladies and gentlemen, when you're calculating for the radius on a circle, you got to be able to get rid of your coefficients here. Divide them out or multiply, whatever you need to do, so you get them isolated, so then you're just equaling to your radius squared. OK? Make sense? This example, guys, is kind of important because this one does get some students mixed up. They realize they don't have a denominator here, and they're like, what should we do? Well, remember, guys, that's just going to represent as 1, right? So again, we're comparing. We're looking for our denominators. We see that 10 is going to represent our a squared, because a squared is always larger than b squared for an ellipse. Since a is, so this is your a squared. That's your b squared. So you could say a squared equals 10. B squared equals 1. A equals square root to 10. B equals 1. And then let's go ahead and figure out c. So therefore, I could do a squared minus b squared equals c squared. 10 minus 1 equals c squared. 9 equals c squared. And 3 is equal to c. Right? Remember, guys, we're not doing the plus or minus because it's just the distance, right? So it's just absolute value distance. All right. So we know that a squared is under the y, so we know we're going to have a vertical major axis. We see that our center here is h and k. Remember, h is always with the x. K is always with the y. So let's go ahead and plot this. 1, 2, 3, down 1. All right. Now, a, that does not look the thing. So we're going to go up square root of 10, down square root of 10. Now, again, where does square root of 10 lie? Well, the square root of 9 is 3. Square root of 16 is 4. So the square root of 10 is somewhere in between 3 and 4. Correct? Now, let's just write down the vertices before we scratch them. So the vertices, again, we're going up and down. Here's the center. So we should be adding the square root of 10 to the x or the y coordinate if we want to go the y coordinate, right? So therefore, this would be, so the center is 3 comma negative 1. So the vertices are going to be 3 comma negative 1 plus or minus the square root of 10. Now, the foci is going to be c away. Now, again, remember, the foci are in the same direction as the vertices. So we're just going to add and subtract. We're going to add and subtract 3 to there. However, I would not like you to, I'd like you to break that up. So negative 3 plus 1, or plus 3 is going to be 2. And negative 3 minus 1 is going to be negative 4. Follow? Yes? Now, we could plot those points since I asked you to sketch the graph. So 3, 2 would be 3 up 2. Negative 4, 1, 2, 3, 4. Let's label these as the foci. And then the vertices, again, this is like 3 point something, right? So therefore, if I was going to do negative 1 minus 3 point something, that's going to be like 3 points minus 3. Hold on a second. Yeah, minus 4. Minus 4, yeah. So if you do 3 and some things, so negative 1 minus 3 and change, that's going to be like 4 and some change, right? So 1, 2, 3, 4, be somewhere down there. And then basically you can see that this, if you were going to take negative 1 plus 3 and some change, that's going to be 2 and some change. So that'd be 1, 2, and some change up there. So it'd be your vertice. You can also take your value of b, which would be 1 unit to the left of your values, right? That's your co-vertices or minor vertices. So it'd look like that, very kind of skinny ellipse, right? Because remember, the distance from your center to your minor vertices or co-vertices is 1. So you're just going 1 unit over, because that's b. B, distance from your center to your endpoints of your minor axis. And there you go. But that and that and that is what you would need. Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph this ellipse. But before I even think about graphing an ellipse and I see all the fractions, I'm like, I don't want to deal with this. It kind of comes upon me. It's like, hey, yeah, it has fractions. But guess what? This is a circle. So it's going to be much easier than actually graphing the ellipse and doing all this fraction stuff, because this is in the form of the equation for a circle, which is x minus h squared plus y minus k squared equals r squared. Right? I don't have my a and b. My r is my radius, which is equal for both for all the vertices. So now all I need to simply do is just determine, well, what is my center and what is my radius? So the center is h comma k, and the radius is r. So in here you can see that my center is, remember, it's the opposite, right? So it's negative 2/3 and positive 1/2. Where my radius is r squared. So we can say r squared equals 16 over 25, square root, r equals square root of 16 is 4, square root of 25 is 5. So now I know the value of r, which is 4/5. So to graph this, I'm going to use a big scale. So that's 1, positive 1, positive 1, that's negative 1, that's negative 1. OK, so, shoot. Let's use 2, 1, 1, 2. I got to change my scale. Just realized. OK, my center is at negative 2/3, which is like 0.666 repeating, right? So it's going to be like here, and then up 1/2. OK, so that's my center. Then my radius is 4/5. Now, if you think of decimal, that's 4/5 is like 0.8, right? So it's almost a distance of 1. And we could figure out all these points if you wanted to. But I'm pretty much just going to estimate up here that where is my radius. I mean, main important thing is determining the values of that. But there's your center, and that's my rough sketch of my vertex of my circle. But again, we could use a calculator just to find actually what it would be, some of those coordinates. But anyways, ladies and gentlemen, that is how you graph a circle with dealing with fractions. Thanks. So, ladies and gentlemen, what we have in this case, we have x squared plus y squared plus 4x minus 10y minus 7 equals 0. And what they're asking us to do is find the center and the radius of the circle and then sketch the graph. All right? So what we're going to have to do for this problem is what we're going to simply do is we need to first be able to determine if it's in our standard form of our equation of a circle. So remember, standard form of equation of a circle looked like this. X minus h squared plus y minus k squared equals r squared. Right? Yes? Does this look anything like that? Because once it's like this, it's pretty easy. We know that the center of the circle, all right, is h comma k, and the radius is equal to r. So as long as we can get it in this format, determining what the center and the radius is pretty simple. Correct? Do you guys agree? OK, so now what we need to do is we need to figure out how are we going to take it from this format to this format. And there's a little bit of process that we started off the class with, which we call completing the square. Exactly. And notice we're going to have to go ahead and do it twice. All right? So x squared plus 4x plus y squared minus 10y minus 7 equals 0. All right? OK? So what we're simply going to do now is, so what I did is I just rewrote it. I'm sorry, that's, yeah. So what I did is I rewrote it with my x's next to each other and my y's next to each other. So now what I can go ahead and do, all right? Kevin, you got this one? Good. So now what I can go and do is now complete the square for each one of these terms. Well, I need to determine, if there is a term in front of my quadratic, then I have to factor it out. Fortunately for us, we don't have any terms in front of our quadratics, right? So we're good. So now I can just take this, and we're going to complete this square. So I'll take my b divided by 2, which is 4 divided by 2 squared, which equals 4. And then over here, I take my b divided by 2, which is my negative 10 divided by 2, and I square it, which then is going to equal 25. OK? Got it? All right. So now, remember, we add each one of those into our components. Now I have x squared plus 4x plus 4 plus y squared minus 10y plus 25. When we complete the square, what we do is we now have taken a binomial and created a perfect square trinomial. All right, but it's important that since we added the 4, we have to make sure that we either subtract it on the same side or add the 4 to the other side, right? Because it's an equation. So if you introduce by adding a 4 on one side, you have to make sure you add it on the other side, or the equation is not going to be equal anymore. So then I have to do the exact same thing for 25. Now, to help this problem along, if you guys notice, in our general formula, it's just x minus h squared plus y minus k squared, right? There's no other room for this minus 7. So what I'm also going to do is add the 7 to the other side. OK, so I'm going to get all the numbers to the other side, except for my x and my y's in the perfect square trinomials. Now, the whole reason why we, again, complete the square is, 1, to create a perfect square trinomial, all right? And then 2, to be able to create a binomial squared. So here, we're going to have x plus 2 squared plus y minus 5 squared equals 4 plus 25 is 29, plus 7 is going to be 36. Now, we know our h and our k, and we know our radius is going to be r. All right? So therefore, yes?
When we get to like the 4 and then put it on the other side, we just have to subtract the 4. What is minus 4?
No, since you're adding it to the left side, I'm adding it over to the right side.
Oh, okay.
OK? Can we wait 2 seconds?
So they don't cancel out?
No, they cancel each other out on the equation. When you add the one to the left side and add it to the right side, they can counter out the balance of the equation, right? So therefore, our center is going to be negative 2, 5. And then our radius is going to equal 6. Because remember, it says it equals r cubed, or r squared. Well, 36 is what squared, which is r, which is 6. OK? All right. So first thing you guys want to do is group. Let's group your variables. Did everybody see what I did? OK? Now, we need to complete the square for the x's, and we need to complete the square for the y's. So in both of these cases, I need to take b divided by 2 and square it. So in this one, it's negative 8 divided by 2 squared. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16. And then here, I have b divided by 2 squared, which is 4 divided by 2 squared, which equals 4. Now remember, when you complete the square, you want to add it inside those parentheses. That creates your perfect square trinomial. And then whatever you do on one side, you have to do on the other side. So in this case, I have x squared minus 8x plus 16 plus y squared plus 4y plus 4 equals negative 11 plus 16 plus 4. Does everybody see how I added everything up? Did you see everything? Okay. Does everybody see the color coding? You see your mistake? Now we can factor these down to binomial squares, right? So therefore, what two terms multiply to give you 16, add to give you negative 8? Here, y plus 2. This adds up to 9. And now, guys, is this in this general form of a circle that we like? Yeah. So we can say the center is 4 comma negative 2. The radius is r squared, which is 3. So what we went over last class period, a circle we know comes in the form of x minus h squared plus y minus k squared equals r squared. Correct? Yes. OK. And we know that the center is h comma k, and the radius is equal to r. All right? So in this problem, Wendy, did they give us, oh, I'm sorry, I didn't write it in there, but yes, this is the center. So did they give us the center? Yes. Did they give us the radius? Yes. Is that all we need to know to write the equation? Yes. So we're just going to plug it in. So remember, it's x opposite of h. So therefore, it's going to be x plus 1/4 squared plus y opposite of k. So it's going to be plus the square root of 3 squared equals my radius squared. And then how do you multiply 5 square root of 2 squared? Well, when we look at this, Wendy, if we say, what is 5 squared, we know that's equal to 5 times 5, which equals 25. If I say, what is 5x squared, that is 5 times x times 5 times x, which equals 25x squared. So 5 square root of 2 squared, that just equals 5 square root of 2 times 5 square root of 2. Well, remember, you can multiply radicals. You can multiply the radicands and radicals. So therefore, this becomes 25 square root of 2 squared, which equals 50. So therefore, my final answer is x plus 1/4 squared plus y plus the square root of 3 squared equals 50. Final answer. OK? So for this point, I have the endpoints of the diameter are 3 comma negative 3 and 1 comma 5. All right? 1 comma 3 and negative 1 comma 5. So what we're going to do for this problem, all right, is, yes?
Do you know they have those tools where you put it in the middle and you can use those?
Sure.
Would that give you accurate?
Sure.
Yes.
So what's the, so you needed to do that, right?
Use center.
Let's just go, I'll call it use that. You have to know what the center is, though, right? So what's the center then?
So we have to figure it out.
Got to figure it out, right? And then how far are you going to set that apart, right? If you're going to use a compass and you're going to want to spread it apart, how far do you spread it apart? So we don't know that information, right? It could be 1 unit, 2 unit, 3 units. So yes, to use a compass, let's go ahead and, Juliana, let's go and see if we can figure out that information. So first of all, what I'd like to do to tell you guys to graph this, all right, the first thing we need to do is find the center, right? We can't find the center unless with this we can't graph it unless we know what the center is. So let's plot our points. So we have 1, 2, 3, 1, 2, 3, negative 3, 1, 2, 3. Then we have 1 comma 5 over 1 up 5. 1, 2, 3, 4, 5. All right. Now, Wendy, when you look at these 2 points, can you determine where the center is by looking at these 2 points? These are the 2 points of the diameter, by the way. So that means they cross directly across your center of your circle. So you could probably guess pretty close that it looks about right there, right? Wouldn't you guys agree that's kind of like the midpoint? Oh, yeah, I did. That's 1, 2, 3. Thank you. It's been like a horrible day for me. Seriously.
Hey, it's Friday.
I guess that's it. So anyways, we can kind of figure out where this midpoint is, right, Wendy? Could you kind of look at this and say, it looks like the midpoint's probably like right around here. Don't know if that's exact, but that looks pretty close, right? So probably maybe a little bit lower. But let's now, what we're going to have to do is algebraically, let's prove where that midpoint is. So we know the midpoint formula, right? So if we say that this point is 1 comma 5, and this point is 3 comma negative 3. So now by knowing these points, if I say this is x1, this is y1, and this is x2, y2, then what I can do is simply find the midpoint. And the midpoint is going to tell me exactly what the radius, or I'm sorry, what the center is. So I do 1 plus 3 divided by 2, comma, 5 plus negative 3 divided by 2. So therefore, I go 1 plus 3 is 4, divided by 2 is 2. 5 plus negative 3 is negative 2, comma 1. So I go over 2, up 1. So my center is right there. I was very close.
Oh, you're finding, okay.
So now I found the center, right? So now if you're going to put a little compass thing, you put it right there, right? And you have to circle it around, correct? But the problem is, how far do you have that compass set out? Do you have it like for a circle this wide, or do you have it for a circle this long, right? So what you need to do is you need to determine what this radius is. Well, obviously, yeah, you could probably use that given point, right? But let's say you don't have one then, OK? You're on an island, and you didn't bring your compass with you. So what you're going to have to do is still find the distance from the center to that point. So you have to find the radius. So do we know how to find the radius? Or to find the distance? Of course we do. We need to now find this point, which we said was 2, 1. Now we need to use the distance formula, which I'll call this x3, y3. All right? It doesn't matter, guys, what you call it, x1, x2, x3. All we need to do is find the difference of these 2 points, or the difference of those 2 points. So I'll use these 2 points to prove my point. So the distance equals the square root of, let's do x3 minus x2 squared plus y3 minus y2 squared. Again, ladies and gentlemen, it does not matter. I could use x3 and x1. Okay? It doesn't matter. I just need to find the difference between those 2 points and square it. So therefore, d equals the square root. x3 is going to be 1 minus, I'm sorry, x3 is 2, minus x2, which is 3, squared, plus y3, which is 1, minus a negative 3. Notice I put it in parentheses.
Can you just put it as a add and plus 3?
Yes, you could. 2 minus 3 is negative 1. 1 minus 3 is going to be 4 squared. So therefore, my distance, which is actually equal to my what? My radius, is equal to the square root of 1 plus 16, which is square root of 17. OK? So now I know my,
Question.
yes?
So you don't have to use in a distance thing, you have to use the center?
Huh?
Like,
I'm asking you what the center and what the radius is on this question.
well, I mean,
So then, if I know at, so I'm sorry. Yeah, my r equals square root of 17. But actually, does it ask me to write the equation? Yeah, it says write the equation of the line, actually. So if I know r equals square root of 17, my equation doesn't ask for r, though. What does the standard equation of a circle ask for? Well, gotta know. What does it ask for? What does my standard equation of a graph ask for? Doesn't ask for r, it asks for r squared. So if I square both sides, I get 17 equals now x minus my h, which is my x coordinate, which is 2. So it's going to be x minus 2 squared plus y minus 1 squared. And that is now the equation of your circle. So I even though I could have graphed it, which you can kind of graph something like that, but if I'm asking for the equation, you got to know what the radius is in the center and how to find it. OK? OK. What we have in this problem is we have a center at negative 6, 5. And we know that the circle is going to be tangent to the x-axis. All right? So first of all, ladies and gentlemen, when creating a circle, we need to make sure we go back to at least write in our standard form, right? So we know that a circle can be written in standard form of x minus h squared plus y minus k squared equals r squared, right? Where the center is h comma k, and the radius is equal to r. Right? OK. So all they're asking us to do is to write the equation of the circle. Well, we know what the center is, right? And remember, it's x opposite of h and y opposite of k. So our equation here is going to be x opposite of -6, so it's going to be x plus 6 squared plus y opposite of 5, which is going to be y minus 5 squared equals, now we got to determine what r squared is. So to do that, I need to first understand what tangent of x to the x-axis is and what our graph's going to look like. So let me just plot this out real quick. So it's -6 up 5. 1, 2, 3, 4, 5, 6 up 5. 1, 2, 3, 4, 5. OK, so roughly my center is right there. OK? Now, what they mean by tangent to the x-axis, all right, means that it's going to touch at exactly one point at the x-axis. So if I was going to graph a circle, I know that it's going to tangent to the x-axis, means that it touches at that one point. All right? So if you look at like a circle, so if I was going to draw a circle here, that'd be -6. That's up 5, -6. Yeah, something go like that. So it looks something like that. All right? So what tangent to the x-axis means that it just touches exactly at one point. So the circle touches at one point at the x-axis. So therefore, if we know that the center and we know that there's another point that's at the x-axis, we need to determine this distance, which we know that since it is -6 over, we know that this distance is going to be 6. Right? Let me give you guys an example. If I say draw a line that's tangent to the circle, this is a line tangent to the circle. It touches at exactly one point. Right? This would be a line that crosses the circle. It touches at 2 points. So if a line is tangent to something, it's going to touch at exactly one point. Make sense? So since this is tangent at the x-axis, it touches at the one point. That means that distance is 6. Therefore, 6 squared equals 36. And that's your equation of your circle. OK? So what they're asking us to do in this equation is to write the equation of the circle. So the main important thing to write the equation of the circle, we have to know what is the general equation of the circle, which was in your notes last class period, Guillermo. And that equation is x minus h squared plus y minus k squared equals r squared. So to write the equation of the circle, we need to know the center and the radius, right? Because remember, the center is in form of hk, and the radius is equal to r. All right? So we go and look at our general equation, and we say, all right, are we provided what the center is? Or do we need to find it? Yeah, we provided the center. That's just h and k. Right? Perfect. Do we know the radius?
Yeah, no.
No, we're not provided the radius, right? So in this problem, we're not provided the radius. However, if I plugged in numbers for x and h and y and k, would it make sense that I could solve for a variable r?
Yeah.
Yes. So I know h and k, that's provided to us. But what could I use for x and y?
4 and 0.
A point on the circle, which they give us, right? Remember, if you guys look at a circle graphed, that's the center, h comma k. Any point that I say is on the circle is a coordinate point, which can represent x, y. The equation of the circle represents infinite many points, Amani, on the circle. So therefore, I can say that's x, y. So now all I need to do, ladies and gentlemen, is plug those points in and solve for r. So x is 4 minus 5 squared plus y, which is 0. Now here's where you got to be careful. It's y minus k, right? Y minus, what is k?
-2.
So it's going to be a positive, all right? Equals r squared. Well, 4 minus 5 is 1. 1 squared is 1. Plus -2 minus 2 is going to, or -2 minus 2 is positive 2. Positive 4 equals r squared. 5 equals r squared.
I'm sorry, I thought you put 4 minus -5 because there's a slash in it, so I put 4 plus 5.
You just put a finger on there. It was supposed to.
4 minus 5. That's all it's going to be for that. So 5 squared is there. If I asked you what the radius was, you could say the radius is the square root of 5. All right? But we're not really talking about what r is. We don't really care, actually, what the r is. We just want to know what the equation of the circle is. So the radius is square root of 5. You square that, and it's just equal to 5. So now that I know the center, can I plug those in for h and k? And now that I know what r squared is, can I plug that in?
Yeah.
And that's the equation of my circle. So therefore, I have x minus 5 squared plus y plus 2 squared equals 5. Notice how it's the opposite. It's opposite h, opposite k. Since h is positive, it's x minus h. Since k is negative, it's y plus 2. Right? So it's the opposite of those. And then we figured out r squared, which was 5. So the first thing we want to do, guys, is identify our h and a k. So we know that it's x minus 4 squared plus y plus 3 squared. The problem is we need to figure out what r squared is, right? And the only thing they don't tell us what our radius. The only thing they tell us is the area of a circle is equal to 36 pi. Well, the area of a circle is pi r squared equals 36 pi. So divide by pi, divide by pi. R squared equals 36. Again, we don't want the radius. We actually want what r squared is, which is just 36. And there we go. That's number 7, which says x squared divided by 25. What? Plus
Y squared.
plus y squared over 16 equals 1. All right, so on this problem, all they're simply asking us to do is find the center, the vertices, the foci. We're not going to worry about eccentricity. You can just live there. We're not going to worry about eccentricity right now, and then we'll sketch the graph. All right, so the first thing we look at is, remember our form. We had 2 formulas, right? X minus h squared divided by a squared plus y minus k squared divided by b squared, blah, 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 blah. So what we want to do is, remember when we were looking at a picture of our ellipse, we knew that a was, or 2a was the length of our major axis, right? Yes? And then b was the, 2b was, was the length of your minor axis. So on our denominator, we either have a squared or b squared. Which one's larger, a or b, when you look at the picture? A is, right? So what I want to do is I want to determine out of my 2 denominators, which one of these is larger than the other. You can look and you say, well, obviously, yes, 25 is larger than 16, right? So what we can have is, now I can say that 25 is equal to a squared, and 16 is equal to b squared. Does that make sense?
Yes.
Okay, so now that I know that this is my a squared is under my x, I'm going to write out that formula. So remember the formula goes x minus h squared divided by a squared plus y minus k squared divided by b squared equals 1. All right? So we look at this and we say, all right, since I know my a squared is under my x coordinate, this was the formula for a ellipse when we have the major axis is horizontal. So I don't know what my graph looks like, but I know it's going to look something like this. Right? It's going to have a horizontal major axis. Okay? So now we know we have our a and our b. Now, first of all, so in this case, to solve for a, it's pretty simple. We just take the square root of both sides. A equals plus or minus 5. Here to find b, we have b equals plus or minus 4. Correct? Okay. So let me actually draw this out again. A little bit nicer. Okay. So here's what we're dealing with, ladies and gentlemen. We know we have a center. We know we have 2 vertices. And we know we have 2 foci. Right? Vertices, center, foci, foci. Now, in our problem, do we know what the center is? Center is HK, right? Center.
Is it 0, 0?
Yeah, 0, 0. Center is H comma K. Well, in this problem, we're not subtracting anything, right? So in this problem, our center is going to be 0, comma 0. Now the next thing it says is find the distance of, let's do our vertices first. So remember, to find our vertices, from the center to one vertice is equal to a distance of A, right? So that means I'm going to have to travel A to the left, and I'm going to have to travel to A in the right direction, right? So now I'm going to be adding and subtracting A, which when we said our vertice takes on the form, when it's horizontally, H plus or minus A, comma, K. All right, now, do we have an H and a K? No, well, we do, it's 0, 0. But we can say our vertice is now going to be at negative 5, 0, and at 5, 0. Notice how we have two of them, right? We have one subtracting it, and then we have one adding it, because negative 5 plus 0 is negative 5, and 5 plus 0 is going to be 5. But notice your vertices are coordinate points. Okay? I'm writing them as coordinate points. Now, let's go and try to find our foci. Here's where it's going to get a little tricky. Okay. Foci, if you remember, has a distance. Anybody remember the distance from the center for your foci? Anybody? Anybody? Who's on the picture I have? C, very good. So the distance from the center to your foci is a distance of C. Now, last class period I gave you guys this formula and we worked on it. I didn't really go through the whole thing, but how do A, B, and C relate to each other? A is the distance from your center to your vertice. C is the distance from your center to your foci. And B, remember, was the distance of your minor axis. Well, what I went through last time was showing you that the relationship between A, B, and C is going to be A squared equals B squared plus C squared.
What is that?
That is how we're going to find. I can go and explain. I'm not going to explain that in this video, but I can go and explain again how we got that. But for right now, you guys just need to understand that A, B, and C are related to each other in this equation. All right, and I'll go and re-explain it again if you need me to. So we need to figure out what C is. Do we know what A is and do we know what A squared is and we know what B squared is? Yeah, all right. We already knew those from right here. So I just say 25 equals 16 plus C squared. Minus 16, 9 equals C squared. Square root, C equals plus or minus 3. So to find the foci, again, notice how the foci is moving along the major axis, right? I want you guys to really understand this. The center, the foci, and the vertices are all on the major axis, right? So is my K of my center ever going to change? The K, the Y coordinate? No. Your K is never going to change on a horizontal one. When it's vertical, the K value is the only thing that's changing, and your H is not going to change. But that's another point. So now we'll do H plus or minus C, comma K. So in this case, I'm just adding plus or minus 3. So I have 3, comma 0, and negative 3, comma 0. And that's how you find the center, the vertice, and the foci. All right, ladies and gentlemen, I just want to make sure I go through this to make sure we're all at least on the same page before I go over the other types of problems we have. So, first of all, again, just like parabolas, we need to determine there's two types of ellipses we can have. We can have one ellipse where we have a major axis of symmetry, like here your x-axis is going to be, the major axis means the longer part is going to be your major axis of symmetry, or we could have it where we're going to have a vertical axis of symmetry. And of course, just like parabolas, these have two different equations, all right? For ellipses, the way that we're going to be able to determine this is we're going to look at our major axis of symmetry has a length of 2a. So it doesn't matter where it is, if it's vertical or if it's horizontal, the distance of it is 2a, all right? And our major axis
What?
During this time? So our major axis is going to be always under whatever term we have. If you look at this, the other term, our minor axis, what we call, is going to be 2b. And you can obviously see that b is smaller than a, right?
Yes.
Okay? So what we're going to look at this is, if I notice what we have is our general form, we either have a squared or b squared, and I'll write out the formula here in a second. But whichever one is larger is going to be your a squared. So I can say that this is going to be my a squared. Since my a squared is under my y coordinate, I know that this is going to be a vertical axis of symmetry. And just think of like the y coordinate, that's going to be, like you're on your y-axis. So therefore, the larger point is going to be stretching along that y-axis. So let's just write out. So now that I know I have a vertical, horizontal axis symmetry, let's just write out the formula: x minus h squared all over b squared plus y minus k squared all over a squared.
Wait, so the a squared is under the y, then it's a horizontal axis?
It's a vertical.
You just said
If it's under the y, it's a vertical. If your a, your larger number, was under the x, then it's going to be a horizontal.
Can you
It's
write
going to be
it down?
stretched horizontally. All right? Does anybody have any questions on how to determine that? Because you're going to have to be able to determine that just like the parabolas. Parabolas is a little bit easier because you remember, oh, x squared, that's vertical, right? Or y squared, that's going to be horizontal. Here, you just need to determine what is my larger number, because a is always larger than b, right? Your a is always larger than your b. Since my a is larger than my b, whatever my a is under, that's going to determine if it's vertical or horizontal. So they want us to determine our vertice, or I'm sorry, first our center. Well, in this problem, guys, remember center is going to be the exact same as our vertex in a parabola. So center is going to be h comma k. In this problem, we have -3 comma 5. Right? So I'll graph something over here. So 1, 2, 3, 1, 2, 3, 4, 5. All right. Now, the next thing is we need to determine what our vertices are. Well, our vertices take a distance on whatever. The main important thing that you need to understand why we have that major axis is because your vertices, your vertex, and your foci all lie on your major axis of symmetry. So we determine that this is going to have a major axis, a vertical major axis of symmetry. And then what I need to do is, if here is my center, I'm going to have a vertical axis of symmetry. So now what I need to do is determine if here's my center, my two vertices, right? We're not dealing with the horizontal, so let's just erase this. So now, if here's my vertex, my two vertices are going to be a distance of A, right? A up and A down. So I need to determine now what is the value of A. Well, we have 25 equals A squared, so therefore A equals 5, correct? So if I say, all right, well, here's my center at -3, 5, and my vertice has to be a distance up and a distance down. Make sense?
Yes.
So the first vertice is another 5 up. So if I'm at -3, 5, 6, 7, 8, 9, 10, and then down 5, which would be at 0. So my vertices are going to be at, they're still going to be -3. The h coordinate did not change, but now I'm going to -3, 10 and -3, 0. Plus or minus 5. I found the value of A, which is 5, and I added it and I subtracted it. So here's my center, here's my vertice, and there's my vertice. I know my graph's not perfect, but it's okay. We cool right now?
Wait, you did what?
Did what?
Oh, I see. Never mind.
The next thing we need to take a look at is now we need to figure out our foci.
You look like I'm stupid.
No, I'm not looking at you, you're stupid at all, but I gave you that look because you were staring right in, I was just,
Because I was spacing out.
I
There's
know.
one person talking.
And it doesn't help when you keep on turning around too.
You need to help me stay away.
Okay, but Aaron, you've covered this so far where we're at.
Yes.
I just found the center and I took the vertices, right?
Yeah.
Aaron, and then we figured out what A, and then I'm adding and subtracting that to there. So the next thing I want to do is we need to figure out what the foci is. Well, ladies and gentlemen, we have an issue with the foci because the foci, the distance of their foci is c. Okay? And the problem with c is, we know that here our minor axis is 2b, our major axis is 2a, but we don't know the value of the c. Luckily, we do have a relationship to find the value of c, which is a squared minus b squared. All right? So we can figure out what the value of c is as long as we know what a squared and b squared are. So I have c squared equals a squared, which is 25, minus b squared, which is 16. C squared equals 9, c equals 9. C equals 3, right? So now our foci is going to be the exact same thing. Notice how our center, our foci, and our vertices all lie on the same major axis. So now, if I know that this distance is 3, all I'm going to do is add 3 and subtract 3 to the y coordinate of your center. So my foci is still going to be negative 3. I'm not moving left or right at all. But now it's going to be negative 3, 5 plus 3, which is 8, comma, negative 3, 5 minus 3, which is 2. All right? And so there, 3, there's my foci. There's my foci. And I'm not going to graph the minor axis. The minor axis would have been 2b, so it would have been 16. So we would have had 2 over 2, so it actually been right there and something like that to graph with the minor axis to go through. But just to give you guys a rough sketch, the main important thing is remembering these are all on your major axis. Okay?
Okay.
For this one, Ava, what they're asking us to do is they're asking us to find the coordinates of the center, the foci, the lengths of the major and minor axes for the ellipse with the given equation. Then we need to graph it. All right. So first of all, we need to understand where is our A and where is our B. Remember, when dealing with an ellipse, Ava, what we have is A is going to be your larger number, because remember, A is your distance of your major axis. So in an ellipse, A is always going to be larger than B. So we can determine that my A squared is under my Y, right? So automatically, I know since my major axis is under my Y, I'm going to have a vertical ellipse again, right? Again, another vertical ellipse. Yes, I read it? Squared? OK. So now, since I know that, that means I'm using this equation, x minus h squared over a squared equals x minus k. Why am I doing, yeah, y minus k squared over b squared equals 1. All right, so now, did I switch the, geez. I'm like just a mess here. OK, we're using this one, y minus k, x minus h. All right, so that's the form we're using, because now we know that since my A is under my Y, we're dealing with a vertical. And they're asking us to graph it. So let's go ahead and figure out what important parts do we need to know. The first one is determining the center. Remember, the center is h comma k. So in this case, when you look at your formula, h is 3, k is 1. Because remember, it's always the opposite. So let's go over 3. 1, 2, 3, up 1. So now I found my center. Now we need to determine our vertices. All right? So let's go and find the main vertices. So the vertices, remember, is going to be a distance of A, right, from the center. So if we know A squared equals 36, then we can say A equals 6. Now, since we determined, ladies and gentlemen, that this was a vertical ellipse, are my vertices going to be above and below the center, or to the left and to the right of the center?
Above, below.
Above and below, right? So to find my vertices, it's going to look like this. Your h is going to remain the same, but your vertices are now going to come in this form of this. So your vertices takes a general form of h, comma, k, plus or minus a. So your h remains the same of your center, right? 3 is not going to change. But now what you're going to do is you're going to add your a to the k. And you got to add or subtract it. So let's go and take a look at this. So my h is 3, right? And my k, my h is 3. My k is 1 plus or minus 6. So therefore, I'm going to have two vertices, which are 3, comma 7 and 3, comma negative 5. All right, and let's look at that. Let's plot those points. So over 3, up 7. 1, 2, 3, 4, 5, 6, 7. Down 5. 1, 2, 3, 4, 5. So what I've done is now just plotted my two vertices. All right. The other way you guys could do this is you know that from the center to the next vertex is 6 units, right? So you could just go to the center and add 6. 1, 2, 3, 4, 5, 6. And you get to your vertice. And then just subtract 6. 1, 2, 3, 4, 5, 6, right? So now what we've just created is our major axis. Yes? Now, there's one more thing that lies on that major axis. Anybody remember? The foci, right? We'll get to the foci here in just a second, though. Let's go and determine now what the covertices are. So the covertices are your distance of b. So we know b squared equals 1, so therefore b equals 1. Now notice the covertices, though, are now going to be, if your vertices are up and down, your covertices have to be left or right. So my covertices is going to be a little bit different equation. Now it's going to be h plus or minus b, comma, k. Because now the h coordinate on my center is that's where I'm going to be moving. So I'm going to be moving 1, shifting 1 to the right, and shifting 1 to the left. But if you just want to look at algebraically, it looks like this. 3 plus or minus 1, comma, 1. So that's going to give me coordinates of 4, comma 1, and 2, comma 1. So let's plot those. So those are going to be my two covertices, right? And you guys don't really need to do all this algebra work, Destin, because when you're looking at this, you can just say, oh, my value of b, I'm just going to move it from the center, 1 to the left and 1 to the right, correct? But then you guys can at least see algebraically how we do this. Now, we talked about our last distances, our foci, right? And the foci is going to be what really what's going to help us out. But remember, our foci is going to equal to c. And we need to figure out what c is. So remember, there was a relationship we talked about. A squared equals b squared plus c squared. That is the relationship of your distance a, b, and c of an ellipse. And remember, c is the distance from your center to your foci. So now I need to solve for c. So therefore, I know that a squared equals 36, which equals b squared, which is 1, plus c squared. So I subtract 1, and I get 35 equals c squared. Take the square root, take the square root. C equals the square root of 35. Now, I can't reduce that, but if I give that a value, that's going to be roughly like 5.89, something right around there, right? It's going to be high in the 8, 9 range, 5 point something. So what I'm going to do, though, is where is that vertice? Remember, my foci have to lie on my major axis. So anyways, just to kind of talk about the foci, to give you guys the general formula, since this is a vertical ellipse, I'm going to be adding or subtracting the foci to my h coordinate. So it's going to look something like this. To my k coordinate. H, comma, k plus or minus c. Now, we're going to come into a little bit of a problem here because we can't add the square root of 35 to my k coordinates. But anyways, it'll look like this. 3, comma, 1 plus or minus the square root of 35. Now, I can't evaluate this. We could go to decimal form. And when you do guys get to decimal form, you're going to see that it's going to be, your foci are going to be like right next to your vertices. All right, because as we talked about, the square root of 35 is 5.9 something. All right, So now, just to go and graph it, connect to my vertices and my co-vertices. And there it is. So now what I've done is showed you the center, the foci, the vertices, and the co-vertices. All right. Now, here's our equation. We want our equation in that conic section form because when it's in this format, it's relatively easy to find A and B. Would everybody agree with me? It's relatively easy to find the center. So what we want to do is we need to, but the main important thing is we have those binomials squared. So we want to complete the square. So to complete the square, though, we have to get our variables next to each other. So I have 3x squared minus 12x plus 5y squared plus 30y. And I'm going to put the 42 to the other side, so I'm going to negate it on both sides. All right? Now that I've grouped them, I'm going to want to create a binomial squared from the x's. And I'm going to want to create a binomial squared with the y's. Okay? But before I can complete the square, we remember from quadratics, we can only complete the square when the coefficient of my quadratic term, the term that's raised to the second power, is 1. So here I have my coefficient is 3. So I got to factor that out. So I'll factor out a 3, and I'm left with x squared minus, oops, I don't want to use that. Use black. X squared minus 4x. And then over here, I have a 5 in front. I don't want a 5 there, so I'm going to factor out a 5. If I factor out a 5, I'll be left with y squared plus 6y equals negative 42. Is everybody good so far with what math I have done? Right? Now we're going to do the completing the square portion. So remember, completing the square is basically taking your linear term, your b, dividing it by 2, and squaring it. So in this case, it's negative 4 divided by 2 squared. So negative 4 divided by 2 is negative 2. Negative 2 squared is going to be 4. And therefore, then we take 6. 6 divided by 2 is 3. 3 squared is 9. So those are the values that complete my square. Those values create a perfect square trinomial. And again, that's so important because I can take perfect square trinomials and factor them down. So when I add them inside my parentheses, it looks something like this.
Wouldn't it be easier to just
No. What?
before when you were factoring,
Yep.
you could also factor out a 5y.
You could factor out a y and an x, right? But that doesn't, the problem with that is that doesn't really help us with what we're trying to achieve. What we're trying to achieve is, you're right, you can factor those out. But what we're trying to achieve is a perfect square trinomial. So if you take out the x, you can't create a perfect square trinomial, right? Now the other thing that I'm doing here is I want you guys to understand I'm adding this 4 and the 9 to both. There was a 5 out here nobody said anything about. Thank you. So what I want everybody to understand is, looking over here, is since I added a 4 on the left side, you have to add a 4 to the right side. You add a 9 on the left side, you have to add a 9 on the right side. But remember, these 4 is not really adding a 4. That's a 4 that's being multiplied by 3. That's why I multiplied that 4 by 3. This 9 is being multiplied by 5. So you had to multiply that one by 5. Does everybody follow? Yes. So again, what I did is I just created now a perfect square binomial. And let's see, that becomes 12, 40, 5. So that's 57. So that becomes 15. Carry the 1. Divide by 15. Therefore, we have x minus 2 squared over 5 plus y plus 3 squared over 3 equals 1. Whew. And we did all that work, and we still haven't even done one thing yet, right? We just put it into the format that we wanted to, right? But hopefully, since we've done, 4 examples now, hopefully we can do the rest of this rather quickly, or at least I'm going to do this rather quickly. hopefully you guys will be able to kind of catch on very quickly. So first thing I'm going to do is I'm going to say the center is 2 comma negative 3. I'm going to say a squared is equal to 5. Therefore, a is equal to the square plus or minus square root of 5. B squared is 3. So therefore, b equals plus or minus the square root of 3. And c squared is going to be the difference of a squared minus b squared, which is going to equal 2. So c equals plus or minus the square root of 2. What? Remember, c squared was a squared minus b squared? It is 5. Oh, OK. So now we still need to figure out what the foci, the vertices, and so forth. Since my a squared is under my x, that means I'm going left or right. Correct? So to find my vertices, if I'm going left or right, should I add my vertices to the x coordinate or to the y coordinate? X coordinate. So 2 plus or minus my a, which is the square root of 5. My co-vertices. So if my vertices I was adding to the x, 2 comma negative 3, right? It's 2 plus or minus square root of 5 comma negative 3. My co-vertices, I'm going to do plus or minus, are going to be going up because my minor axis is vertical. So therefore, that's going to be 2 comma negative 3 plus or minus the square root of 3. And then last but not least, my foci is going to be, again, my foci is along my major axis, which is horizontal. So I'm going to do it just like my vertices. So it's 2 plus or minus the square root of 2 comma negative 3. And I didn't sketch my graph, but I'm kind of running out of time. And hopefully you guys would feel comfortable sketching the graph with just estimating would be fine. So we have find the center, vertices, foci, and eccentricity of the breadth. All right. So to do all this, we know we need to figure out A, B, C, right? We don't really need B unless we need to figure out A and C. And we need to find H and K. Well, the only thing we've learned how to do that, ladies and gentlemen, is when we had it in our standard form. Is this in our standard form? No. No, right? We always had x minus h squared divided by either a or b plus y minus k squared divided by either a or b and then equal to 1. So what we have to do is write this in that format. Once we have it in the format, is it much easier to find a and b? Yeah, because a and b are what your denominators are. And then we can use the formula to find c, and then we already know what h and k are. So one thing I noticed about that standard form is I had the x plus the y, right? X plus the y. It was x minus h squared, and then plus y minus k squared. So what I'm going to first do is let's group the x's and the y's. And then I'll get that constant over there. So I have 4x squared minus 8x plus y squared plus 4y. And let's add the 8 to the other side. OK? Now, looks a little bit closer. We have the x's, we have the y's, and we have an 8. However, that wasn't the formula, right? It was supposed to be x minus a number. So I need to get this x minus h squared. I need these x's to look like this, right? This to look like that, correct? Right, and the only way we can do that is what this is remember, this is a binomial squared. A binomial squared. The only way we get a binomial squared is when we factor a perfect square trinomial. So I need to take this and make it a perfect square trinomial. And the only way that we've learned how to make a binomial into a perfect square trinomial is by completing the square. Completing the square. So to do that, let's take it. So we have 4x squared minus 8x. I need to complete the square. I need to make this a perfect square trinomial. Remember, the first step in completing the square is you cannot have a coefficient of anything besides 1 in front of your quadratic term. So the first thing I do is I factor out a 4. Right? Then, remember, we do our special little case in doing b divided by 2
Why don't you
and square it. Huh?
Why don't you can't equal an x?
You can, but remember, we want to keep this as a quadratic. You could factor out an x, you're right. But if you factor out an x, then you're not going to, remember our whole purpose of completing the square is not to factor it, but to create a perfect square trinomial that's quadratic, right? So we do b divided by 2, which is, and then I do negative 2 divided by 2 squared, which equals negative 1, which is 1, right? So I have 4 times x squared minus 2x plus 1. So let's write that in there. 4 times x squared minus 2x plus 1. But now, ladies and gentlemen, remember, whatever we do on one side, we always have to do on the other side, right? Now, what did I do? What did I actually add to this right side? 4, right? Because I added a 1, so from here to here, I added a 1, but that 1 is being multiplied by 4. So over here, I'm also going to have to make sure I add 4. Right? Do you understand from this step to this step, what's the only difference? I added a 1, right? Well, this is factored down to a trinomial, but I added a 1. Okay? And by adding that 1, but that 1 is being multiplied by 4 outside the parentheses. So therefore I need to multiply it over here. Now let's go and do the other one. The other one is y minus k squared. Well, in this example, I have y squared minus 4y. I need to create this to be a perfect square trinomial. So I do negative 4 divided by 2 squared, which equals 4. So now I'm just going to add 4 to both sides.
Wait, why is it negative 4? I mean, I know it doesn't really matter, but...
Negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4.
Where did you get negative 4?
I don't know. I
Right
rewrote it
there.
wrong. Oh, I just wrote y minus k.
Okay.
You're right, it's positive 4.
I didn't think it mattered. It's a little confusing.
So therefore, this, as a perfect square trinomial, is y squared plus 4y plus 4. Now, I'll keep these in parentheses, because now, so now I added 4, so I have to add another 4, right? Yes? Okay. So now, why do we complete the square again? Why do we care that these are perfect square trinomials? The reason why we like perfect square trinomials, and the reason why we have to complete the square to create perfect square trinomials, is because when we factor these, when I factor this, it creates a binomial square. When I factor this, because I completed the square to make it a perfect square trinomial, its factored form is a binomial square. So let's go and factor them to their binomial square. So we're almost there, right? Not looking too bad. However, we don't have an a and or b, and we don't have it equal to 1. So, to make this equal to 1, I can divide by 16, right? So we know now this, that goes to 1. This is just going to remain the same. Y plus 2 squared over 16. Plus this reduces down to 1/4. Okay, so almost there. All right, so now, ladies and gentlemen, we have it. So we went from this to this, right? This to this. Now, since it's in this form, they said find the center. Can we easily find the center? The center is?
Negative 1, 2.
Close. Remember, it's
Oh, yeah,
opposite of h, opposite of k, so the center is?
2, 1. 1, negative 2.
Right.
Ah,
1, negative 2. If you just keep on yelling out, you'll get it. But yeah, just remember it's the opposite of h and k, okay? And remember, x is in the ellipses. X is always going to be with your h. Same thing with parabolas, right? Yes. Good. Yes. Okay. Good. So we have center equals 1 comma negative 2. Then they say find the vertices. Well, ladies and gentlemen, the vertices are how far away from the center.
2, A. 2, I don't know, really. 2.
What did you just
A.
say?
Hey. Okay. Let's stop. Let's take a break here. First thing we need to do before we even start talking about vertices and foci, let's look at this graph. Is this graph going to be
Vertical.
horizontal or vertical? Vertical because our larger term, which is our a squared, is under the y squared, right? So let's go and plot a graph of this real quick. Doesn't need to be pretty. So now we know, since it's a vertical, because my a squared is under my y, I know that I have foci and vertices. Now, we said the center is at 1, negative 2. Let's go and determine what the vertices are. Now remember, this distance from the center to a vertice has a distance of a. And we're saying that a squared, remember a squared is always your larger, right? Because if this is a and that's b, right? So what we're saying is your a squareds, that's your larger one, and since it's under the y, that's what's made it vertical. So if I'm saying that 16 equals a squared, what is a?
4.
4, very good. Plus or minus 4 though, right? Because notice, look at my center. I have to add 4 and I have to subtract 4, right? To get to my two vertices, I have to add and subtract. So it's plus or minus 4. Now, am I plus or minusing that to the h value or the k value of my vertex? The x or the y, as you could say. The y coordinate, right? Which is your k. So therefore, my center, 1 is going to remain the same, but it's going to be negative 2 plus or minus 4. Does that make sense?
No, it really doesn't.
The 1 remains the same. The center, the y the x value remains the same. They're all on the major axis. What's your question?
I don't understand. Just keep going.
What
She
you got?
wasn't here last. I wasn't here last class.
Okay.
So she doesn't know that.
We can go back through it. So therefore, we have our center is officially going to be at, I'm sorry, your why am I rewriting?
Yeah, that's what.
No wonder you're not making sense.
You don't know what you're doing.
Yeah, I can't even write it in the sentence. So your vertices are going to be at 1 comma, 1 comma 2, and
1 comma negative 6.
1 comma negative 6. How about I just write everything as labeled as center, and then you guys can just guess what it
I don't
is.
read yours right, I don't care.
So therefore, your vertices, you have two vertices, right? Your vertices is 1 comma 2 and 1 comma negative 6. Notice how they all have, your center and your vertices all have the same x coordinate, right? Because they all lie on the major axis. Last thing we need to do is find the foci. Well, ladies and gentlemen, foci has a distance of c. And we got a little issue with that because do we have a c in this formula? No, but the only thing we do know is a squared equals b squared plus c squared, right? And do we know what a and b are? Yes. A is 16 equals 4 plus c squared. So by doing a little bit of work, we could say c squared equals 12. Take the root of both sides. And I could say c equals the square root of 12. We can reduce that down to 2 radical 3.
Must we?
Huh?
Must we?
Yes. Okay, so I'll finish my work over here. So we have the center of the vertices. Now to find the foci. The foci is the foci gonna have the exact same x coordinate as the center and the vertices?
Yes.
Yeah, so we know it's gonna be 1, right? 1 comma plus or minus
2 comma.
the
Or
vertice or the center, which is negative 2. Negative 2 plus or minus, what's my value of c?
2 square root of 3.
2 square root of 3. Now, can we add a 2 square root of 3 to a negative 2?
No.
No. So we can just write our foci as 1 comma negative 2 plus 2 square root of 3, and our other foci is 1 comma negative 2 minus 2 square root of 3. Do not give me decimal form. Leave this in the exact form. All right? So now we have our foci, center, and our vertices. Now, I did say we'll do eccentricity. Let's just try to write it real quick. So the eccentricity, guys, remember, is a ratio of c divided by a. So just take your c which is, I don't remember where it is, 2 divided by square root of 3, divided by your A, which is
4.
4. And there's your eccentricity. And obviously, remember, as we talked about that, as that gets closer to 1, that's so you can see how that's going to be spread out. As it closer to 0, that's the closer it's going to get into a circle. Okay? It's a lot. So, ladies and gentlemen, hey, there's no gentleman here today. Oh, look at that. You know what I told you guys about my first job? I'll say it. My first interview. Yeah, it's on video. My first interview, though, was in a school in Jacksonville. And before I even accepted on the Mandarin, they asked me, the only position they had open was for a math teacher, but it was for like the early pregnancy. So it was like for all the girls in the city, like that would, that were having a baby, that I would be like their math teacher. So, just fresh out of college, and they say, oh, do you think that would be a good fit? I'm just like, sure. Classroom full of ladies, the women that are all ready to have a baby, that sounds like a good idea. Unfortunately, they didn't give me a call back, so I wound up here. But
Are you filming
anyways,
this right now?
yeah, I that'd be a fun intro, I guess. So anyways, so we're given the vertices, -6, or plus or minus 6, comma 0, and the foci is plus or minus 2, comma 0, and I'm asking you to write the equation. So, ladies and gentlemen, remember the parabolas when I said I was giving the information? The first thing I said is just, there's only 2 equations. It's either opens up or down or left and right? The only way to figure that out is to plot the information and see what's going to make sense. Exact same thing with this. So let's just plot the information and see what makes sense. So our vertices are plus or minus 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Foci, plus 2, negative 2. So we have foci, vertice, vertice. Now remember, ladies and gentlemen, there's only 2 ellipses that we're dealing with. One that's vertical, and one that's horizontal. Now, just out of, I don't know, a random guess, if you were to say these are the points of one of these ellipses, would you recognize that it to be a ellipse where your major axis is vertical, or where your major axis is horizontal? Horizontal, right? It's pretty obvious. You can notice that, that the vertices, the foci, all have to be on the major axis. And since this major axis is going horizontally, then you have a horizontal ellipse, right? So let's just eliminate this right here. All right. Now, remember, when we're looking at this, if I give you the vertices and the foci, remember, the vertices and the foci are plus or minus the same distance from your center, right? If I say your vertice is 6 units to the right, then it was also 6 units to the left, correct? So therefore, what is going to be our center? Because we need to figure out what this center is.
It's always 0, 0.
In this case, the center is 0, 0, yes.
No,
Oh, the problem actually said,
it starts with the
oh, that's nice. You're right, they do say the center's at the origin, so that's good. Good. Right, you're right, because all the way up to 35, then they change it to 9. Okay. So we have the center is 0, 0. So that helps us because now when we write our equation, we know our formal was x minus h. For a horizontal, then it would be a squared plus y minus k squared over b squared equals 1. However, do we have an h and a k? Yeah, there's 0, right? So now we can just say x squared over a squared plus y squared over b squared equals 1. Okay, so now let's just go and see if we can figure out what our a and b are. Remember, a is going to be this distance, right? Doesn't matter if it's going to be your positive or your negative. What is this distance? What is this distance squared? Well, the distance was 6, plus or minus 6. You square a negative 6, you square a positive 6, it doesn't matter. You're going to get
36.
So now we have y squared over, b squared. Now our problem is we don't know what b squared is, right? But the other information they gave us was they gave us c. And we remember we talked about A, B, and C are related to each other, where we can say a squared equals b squared plus c squared. So if I know a squared is 36 equals b squared plus c squared, so c is 2, so c squared is going to be 4, minus 4, I get 32 equals b squared, square root, b equals plus or minus. Take the, simplify this into 4 radical 2. Yes, but we don't need to do that, right? Because all they're asking us is what is b squared. So we can just leave it like that. B squared equals 32. Okay? Because remember, you're looking for b squared, so we don't need to solve for b. We just need to know what b squared is. So there's your answer.
So in the like standard form of like that graph, where's B? Again?
Where's b?
Yes. Is it? No, in the graph. Like the relationships.
Oh. B is your distance. These are like, if you call this like a major vertice, call this like a minor vertice. It's where it's like the minor vertices on the minor axis. All right, any last questions? Again, the first thing, Ryan, what I talked about last time, the first thing you want to do when you're doing a problem and you're given information is you always want to plot to draw the information, right? Plot that information. So we have vertices and we have co-vertices, all right? So let's plot the information. So I go over negative 3, 8, 1, 2, 3, 8, 1, 2, 3, 4, 5, 6, 7, 8, to 9, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so those are your two vertices. Then I found my two co-vertices, which is at 3, 12, and 3, 4. So 1, 2, 3, 12. So that was 8, 9, 10, 11, 12. And then at 3, 4. 1, 2, 3, 1, 2, 3, 4. So those are my co-vertices. So which one is longer? The distance from vertice to vertice or co-vertice to co-vertice? Vertice to vertice. And remember, the vertice to vertice is what we call your major axis. And so if we know our major axis, what else lies on our major axis? Our foci and our center, right? Now, they're just asking us to write the equation. Now, remember, the equation doesn't deal with foci. We don't have to find the foci to write the equation. So all we need to do, though, is find the center. So remember, the center is going to be halfway in between. It's really going to be halfway between our two vertices and our two co-vertices. So we need to find the midpoint, right? So you could use the midpoint formula to help you out. If you guys forget the midpoint formula, maybe we could do it, but you could easily just find the midpoint of these two, right? Negative 3 plus 9 divided by 2. 8 plus 8 divided by 2. Right? Find the midpoint. Anybody? Bueller, 6. So it's 3, 8. Huh? Yeah. So you can easily find the midpoint formula, and therefore you get 1, 2, 3, up 8. So we know our center is at 3, 8. You can also do the midpoint between your two co-vertices. All right. So now, quick, since we know our major axis is horizontal, in our formula, is our a squared going to be under the x or under the y coordinate? Does anyone remember? It's going to be under the x. Very good. So our equation is going to look like this. X minus h squared plus y minus k squared equals 1. Since it's a horizontal major axis, my a squared is under my x, and my b squared is under my y. Now, what I simply just need to do is say, all right, what is the information I know? To write this equation, I need to know what a equals, b equals, and I need to know what the center is. Well, we found the center by using the midpoint formula. The center in this case is 3, 8. All right. A is the distance from the center to my vertice, which we can say is 6. And B is the distance from my center to my co-vertice, which we can say is 4. 1, 2, 3, 4. 4. So if a is 6, then a squared equals 36. If b is 4, b squared equals 16. Now let's just plug in the points. Remember, this is your h comma k, right? Center comes in h comma k. So therefore, our formula is x minus 3 squared plus y minus 8 squared equals 1, divided by a squared, which is 36, divided by b squared, which is 16. Done, son. Follow? Questions? Yes, Brittany. 6 for A. A was the distance. Remember, A is the distance from your vertice to your center. So since you graphed it, you can simply just count, right? Or you could use your midpoint and say, oh, negative 3 plus 9, that center was 6, right? Or the distance from one to the other was 6. OK? And that's wrong. That's 6, right? No, that's 3. Oh, OK, 1, 2, 3, 1, 2, 3. OK. Huh? A is the, this is A. Yeah, you can simply just count negative 1, 2, 3 or 1, 2, 3. So A is going to be 6. Right? That's how I just counted A equals 6. No, there you go. Sorry. Good? Of course. Welcome, ladies and gentlemen. So what I'd like to do is show you how to determine how to write the equation given the foci and the covertex of an ellipse. So the first thing we want to do is identify, do we have a major axis that's horizontal or vertical? So to do that, we need to at least write in the information that we have. OK, so the foci, which is at 4, 4, and 4, 14. So 1, 2, 3, 4, 1, 2, 3, 4. And then at 4, 14. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. OK, so remember, these are the foci. And then the one covertex is at 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. OK, now, what's nice about the information that we have is notice that the major axis, what lies on the major axis is the vertices, the foci, and the center. So therefore, I know that this has to be my major axis. Therefore, my major axis is vertical. Since I know my major axis is vertical, I'm going to write the equation x minus h squared plus y minus k squared equals 1. Since it's vertical, I'm going to have b squared under the x and a squared under the y. I'll get to the a and the b in just a second. The next thing here is one covertice. Now notice that, again, when we're looking into trying to determine the center, right? And the center of an equation is in the form of hk. Well, what's nice about the center is the half distance between your two foci, as well as the half distance between your two covertices, and the half distance between your two vertices, which we don't have anything for yet. So if I wanted to find just the half distance of my two foci, I can reason that my center, I'd probably say the half distance is going to be somewhere right around here. Now, since the covertex is 1, 2, 3, 4 units away from the center, or at least the major axis, it has to be 4 units to the other side. 1, 2, 3, 4 on the other side. All right. The next thing to also understand is that this is what we call the minor axis. And the minor axis and the major axis have to be perpendicular to each other. Now, let's get into some fun stuff. The distance from the center to our covertex is what we call, which we give the value of b. The distance from the center to the foci, or one of the focuses, is going to be c. So we don't have c in the equation, but we're going to need to know c to help us figure out what a is. The center, we did determine, is going to be at 4, 9. So I'll say center is at 4, 9. That's the x and the y coordinate for my center. The value of b, the distance from the center to one of my covertexes, is going to be 4. So, I'm sorry, let's write out r. So I can say b is equal to 4 And A is going to be equal to the distance from my center to my vertice, which I don't have. However, there is a relationship of A, B, and C. So we have C squared is equal to A squared A squared minus B squared. So C squared, which we know is the distance from the center to the foci, which is 1, 2, 3, 4, 5. So I have 5 squared is equal to A squared, which we're trying to figure out, minus B squared, which would be 4 squared. All right, remember C is the distance from the center to foci, so that becomes 25 is equal to A squared minus 16. Now add 16, and I get 41 is equal to A squared. So therefore, ladies and gentlemen, A would be the square root of 41. So we know B squared is equal to 16, and A squared is equal to 41. So now we know what A squared is, B squared is, and our H and our K, which is our center, we can now write the equation, which would be x minus 4 divided by 16 plus y minus 9. Oh, I'm sorry, these are all squared. Divided by 41 equals 1. So there you go, ladies and gentlemen. That is how you write the equation of ellipse given your foci and a covertex. Thanks. All right, so what we have, ladies and gentlemen, is we have a foci of 0, 1, 4, 1, and a major axis symmetry of 6. So the first thing I always like to do, especially when what they're asking us to do, is find the standard equation for this ellipse. So the main important thing is I want to kind of see, am I dealing with one that's going to be horizontal or vertical, right? Because those are two different formulas, correct? So the first thing I like to do is try to see if I can get an idea. So I have 0, 1, and then 4, 1. 1, 2, 3, 4. Okay? 1, 2, 3, 4, 1. So, ladies and gentlemen, if I have my two foci like this, is that going to produce an ellipse that's going to be vertical or horizontal?
It can go both ways.
Huh?
Can't go both ways.
Well, let's take a look at it and remember what they have. If it's horizontal, remember you have the center, the foci, and the vertices. The center, the foci, and the vertices all lie in the major axis of symmetry. If it's a vertical, remember center, foci, vertices, center, vertice, foci, center, foci, vertice. So it's either one of these two. If I only know these two dots, what does it have to be? It's horizontal, right? Because these two, your two foci, lie on your major axis. So now we know that my major axis has to be horizontal. So that's very important because now I know at least the formula is going to look like, which is x minus h squared over, since it's horizontal, we know that my value of a, which is my, or 2a, which is my major axis, though, is going to be under x, plus my y minus my k divided by b squared equals 1. Okay, so now we know that's the formula we're going to use. We just need to be able to figure out what a, what b, and what y and k are, right?
Are Y and K?
Y and k are going to be our center. Right now, we don't know what our center is. So let's go back and look at our two foci. Remember, when you're dealing with the foci, I don't know why I erased this, so let's go back to this. So now we know we have a horizontal, right? Okay, so we have a center, foci, and then two vertices. Now, so far, ladies and gentlemen, I've been giving you the foci. I gave you two foci. I didn't give you the center. Do we know the distance from the foci to the center? It is a distance of c, right? And is it this exact same distance? Right, it's the exact same distance of c. So, ladies and gentlemen, if I went a distance from one foci to the next was 1, 2, 3, 4, so therefore, if this distance was 4, what is the value of c? 2, right? Because your vertex is going to be split in between your two foci. So for right now, I'll just write in c equals 2. Therefore, my vertex is going to be split right in between them. So now I know my vertex is going to be at 2, 1. That's pretty good to know, right? Now my vertex is at 2, 1. Now, we got to figure out what A is. We're given the two foci, right? When we know that the two foci, the vertex is right between them, right? And they all lie on the same axis symmetry. So, if I know that my vertex is going to split these 2 points, so I pretty much, from going from one to another is 4 units, I know between them is only going to be 2 units. And then they both have the same K because they all lie on the same axis, right?
Do you mean
Huh?
center?
Center, yeah. Well, I said, what do you mean? No, I mean center.
You're saying vertex and not center.
Oh, center. All right. So now we need to figure out what our A, B, and C are. Well, they said the major axis symmetry is A, or is 6. So what that means is this whole length is 6. But remember, ladies and gentlemen, we talked about half of that is A. So the other half would also be A. So therefore, we can say 2A equals 6. Therefore, A equals 3, right? Does that make sense? The whole major axis is 6. We know that from one vertice to from the vertice to the center is equal to A, so that's 2A, so therefore we get 2A equals 6. So now we do C, A, but we need B, right? That's our last piece of information. We need to figure out what B is. So remember the formula that I said you had, which I explained to you guys over there, which you just need to remember, which is A squared equals B squared plus C squared. So now let's go and plug in our information we know and let's solve for B. So A is going to be 3 squared equals B squared, and then we have C squared, which is 2. So we have 9 equals B squared plus 4, subtract 4, 5 equals B squared. Now, you can say, oh, B is the square root of 5, right? But we don't need to know what B is. We just need to know in this case what B squared is. Because all they're asking us to do is find the standard form. So now, here's our standard form. Let's plug in what we know. Do we know H and K? Yes. Do we know A? Yes. Do we know B? Yes. What do X and Y represent again? Why do we not need to figure those out?
Those are just random points.
X and Y, yeah, represent all the points on the ellipse. So we don't have to have points in there because they represent all of them. So therefore, our final answer is going to be X minus 2, because remember the formula says opposite of H. Since H is 2, it's X minus 2 squared plus Y minus 1 squared divided by A squared, which is 9, divided by B squared, which is 5, equals 1. Ta-da!
So you don't even have to find the eccentricity?
Not for this problem, it just said to find the equation. I think on the next one we're going to do eccentricity. What they want us to do is find the right, or write the standard form of the equation. So when looking at this, first of all we need to determine is it going to be horizontal or vertical. So again, what I like to do is just kind of plot the points. My vertices are at 0, plus 5, and 0, negative 5. So, ladies and gentlemen, am I going to have a vertical or a horizontal?
Vertical?
Vertical, right? So therefore I know now exactly the formula that I'm going to have to use, which is going to be x minus h squared over b squared plus,
Over A squared.
well no, it's going to be vertical. So y minus k squared is going to have a squared. Remember, if it's vertical, your major axis A is going to be under your y. If it's horizontal, the A will go under your x. Okay? All right. So, we know here's our 2 vertices. And that's all we got. Now, we also know the center's at 0, 0. Right? So, ladies and gentlemen, do I really even need my h and my k right now? They're 0, 0, right? X minus 0 is just x. So I'm going to simplify this equation just to x squared over b squared plus y squared over a squared equals 1. Make this equation a little bit simpler. Right? All right. But they did tell us it goes through a point 4, 2. 1, 2, 3, 4, 2.
What is that verb?
what is a point? Remember, we actually even talked about it before in class again. So we have an A, B, and X and Y. We know A is the distance from the center to your vertice, which in this case is 5, right? So if A equals 5, then we can say A squared equals 25. So let's rewrite that. Okay? But our problem is, we don't know what B is, or we don't know what the distance to the foci is. But we do know what a point is, X, we do know point 4, 2, which, remember ladies and gentlemen, when you're dealing with an equation, and your X and Y coordinates represent all the possible points on your graph. Because remember, for this ellipse, how many points are there on an ellipse? 1, 10, 20, 30?
So many.
There's infinite many, right? And remember, X and Y represent all of those points. But if they give you one point that's on the ellipse, we can use that to help us find our other values. So what we're going to use is we're going to say, all right, 4 is going to be X squared. Actually, I'll just keep it. I'll plug this in a second. So we'll say 4 equals X squared divided by B squared, which we do not know, plus Y squared, which we'll say is 2. And then we said A squared, which is 25, equals 1. Now we got to do a little mathematics. 16 over B squared equals plus 4 over 25 equals 1. Well, guys, going back to Algebra 1, I know you automatically get like the sickness. You see, oh no, I have fractions and I have to add, subtract, and do all that kind of stuff. But that's all we're going to do, ladies and gentlemen, is just go back to, I promise it won't be that bad. So now, to solve for B squared, I'll subtract minus 4 over 25.
Can I like cross multiply them? Is that possible?
You can't cross multiply them until you have a proportion, which we'll do next, which means we're going to have a fraction equal to another fraction. So now I have 16 over B squared equals, well, what's 1 minus?
21 over 25. Right.
Well, 1 minus 4 over 25. 1 rewrites to 25 over 25 minus 4 over 25, which, yes, is 21 over 25. Now you have a proportion. So now if you want to solve by cross multiplication, you can. There's other ways to do it. So you can do 16 times 25 equals B squared times 21. Now I don't have my calculator with me.
400 equals
This is what?
400.
Equals,
21 B squared.
and then you divide by 21.
Wait, is that a 216?
No, it's 21 times B squared.
Equals 19.0476.
0 what? 7 6?
476. 476.
And then square root. You check my notes with this, and then you take the square root, and what do you get? Oh wait, you don't need a B squared, right? We don't need it, we just need B squared. Right? We don't need a above B. Sorry. We just need the B squared. So now, if we have X squared over, since it's horizontal, we can say 19, which I'll just round it to our, actually 0.05, equals, why am I saying equals? Plus Y squared over A squared, which is 25, equals 1. And let me just double check my work to make sure I had everything correct. I figured we probably made a mistake. So let's go and take a look.
Well, wouldn't you? I think the book's wrong.
I think half the time it's looking wrong.
Let me see what my...
The book says like 400 in it.
I really hope that wasn't open.
Wow, that was a waste. This one's wrong.
Why is it a waste?
It was wrong.
Okay, well there was a mistake in there somewhere, so that doesn't mean the whole problem is like a waste. What problem is this? 23?
Yeah. It says 21x squared over 400 plus y squared over 25. We had those numbers. We did some.
23?
33.
Oh, okay, I was gonna say. Well, what's 400 divided by 21?
That was the 19.
Yeah, it's right there. They just left it in fractional form. That's decimal form. It's all right. So what I have, ladies and gentlemen, is y divided by 25 minus, I'm sorry, y squared divided by 25 minus x squared divided by 81 equals 7. Right. So what they are asking us to do is, for this problem, is they find the center of the vertices, the foci, and the equation of the asymptotes of the hyperbola, and then sketch the graph. So the first thing, ladies and gentlemen, that we need to do is determine, is this going to be a hyperbola where our transverse axis is going to be vertical and horizontal? And the easiest way to do that is just to plot the points that, or I'm sorry, we don't know that because I'm thinking of a different problem. Anyways, let's look at our two equations, for one for horizontal and one for vertical. So our two formulas for horizontal, the formula for horizontal looks like this: x minus h squared over a squared minus y minus k squared over b squared equals 1. And then for vertical, we add y minus k squared over a squared minus h minus, x minus h over b squared equals 1. So by looking at this, ladies and gentlemen, just trying to see, just maybe comparing the x's and the y's, what does this one look like? Vertical, right? So let's just erase this horizontal equation. We don't need to worry about it. All right, now, just from knowing this, remember a and b are always in the same spot for a hyperbola, right? It's always a squared minus b squared. So in this case, do we know what a and b are? So we can say a squared equals 25, b squared equals 81. Right? Then we have, so also by looking at this, we have a squared equals 25, b squared equals 81. The center, are we subtracting anything, h and k's? Is there any numbers we're subtracting? No, so we know the center is going to be 0, 0. Very good. So now, we know a and b already, so that's good. But remember, to find the foci, we need to find c, right? We need to be able to figure out c is. So remember, the formula for a hyperbola in the relationship between a, b, and c is different than it is for an ellipse. So the relationship, remember, is c squared equals a squared plus b squared, right? It's a little bit different with an ellipse, or with a hyperbola. Right?
I thought it was. Yeah. Me too.
So let's do that. A squared equals c squared minus b squared. If I add the b squared to the other side, is that the exact same equation? Yes. Okay. So it doesn't really matter. The only reason why I wrote it like this is, one, so you guys understand. You can use it either way. And I chose this way just because I want to figure out what c is. So I want c by itself. So that's why. So here we just have c squared equals 25 plus 81. Right? So that becomes 106. C squared equals 106. All right. And then can we rationalize 106 or something like that? I don't know. I'd have to go take a look. So now let's just go ahead. So we found the center. To find the vertices. So, ladies and gentlemen, we know this is a horizontal one. Or, I'm sorry, it's a vertical. So remember, we're going to have our foci, our vertices, and our center all lie on the transverse axis. So if our center is at h, comma, k, the vertices and the foci, they're all going to lie on that same line, right? So what's going to be unchanged, the h or the f, or the k? What's going to be unchanged for all these points? The h. The k, you're moving up and down, right? So the k is always going to change. However, the h coordinate is going to be exactly the same for all of these points. Does that make sense? So to find the vertices, remember the vertices is just going to be h comma k plus or minus a, right? Because all we're doing is adding or subtracting a. Because the distance from your center to your vertice is going to be a. So we figure out if a squared is 25, then we know that a equals 5, right? So our vertice is going to be 0, comma 0 plus or minus 5. So therefore we have 0, comma 5 and 0, comma negative 5. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I kind of write a bad graph, but we'll go with it. So the foci is now going to be h, comma k. But now what am I adding? What is my distance for my foci? Huh? C, right? So it's going to be plus or minus c. Because h, remember, is unchanged. Well, in this case, I have h, comma k. If c squared equals 106, square root both sides, c equals the square root of 106. Okay? I don't know if that's simplified. Yeah, but I want to see if there's a square number that we could have. No. I just wanted to check with it. No, it doesn't look like it works. Okay. So there's so it can't be simplified to 106. So we can't simplify it. So it's gonna be h. I'm not reading that again. So your foci is going to be 0, comma 0 plus or minus the square root of 106. So your foci is going to be 0, comma positive 106 and 0, comma negative 106. All right? And then we already know the center is at 0, 0. All right, and now the last thing we need to do is we need to find the equations of our asymptotes, right? So when we're looking at that, and I had, there we go. So my asymptotes is going to be y equals k plus or minus a over b times x minus h. Right, that was the formula I gave you guys. So now we just need to plug in what we know. Do we know what h and k are? Yeah, they're 0, right? So it becomes y equals a over b. A is 5, b is 9. So it's going to be plus or minus 5/9 times x. So you're going to have two asymptotes, y equals 5/9 x and y equals negative 5/9 x. Yes?
On the graph,
Yep.
you had a point plotted at 5, but what's the one above it?
This one?
Yeah.
Square root of 106 and negative square root of 106.
Okay.
We don't have an exact value for that, but we can give you approximation. The square root of 106 is going to be 10.29. So the vertice is at 5, and the focus is at 10.29. Okay? Any questions on that? No? Good? Exciting? All right. So ladies and gentlemen, what we have is we have the equation x minus 1 squared divided by 4 minus y plus 2 squared divided by 1 equals 1. And what they're asking us to do is find the center, vertices, foci, and the equation of the asymptotes of the hyperbola and sketch the graph. Okay. So, excuse me. So what we're going to do before we get into all this crazy kind of stuff, let's just write down the information we know. Okay? Let's not get crazy. Let's just write down the information that we know. So the first thing I think is always the easiest to remember is the center. We have an h and a k here, so we know that the center is, remember, it's x opposite of h and y opposite of k. So therefore we know the center is going to be 1, comma, negative 2. Right? Now they have to sketch a graph, so we might as well just start graphing as we go. So the center is at 1, negative 2. We'll just locate that with a little c. All right? Now, the next thing is we need to understand, remember the standard form of an ellipse says x minus h squared all over a squared minus y minus k squared all over b squared equals 1. Always for a hyperbola, it's a squared minus b squared. Always. An ellipse, the a's and b's can swap, right? But a hyperbola, it's always a squared minus b squared. So how do you determine if it's going to be a horizontal transverse axis or a vertical transverse axis? All depends on which coordinate is above your a. So since my x is above the a, I know this is going to have a horizontal transverse axis. What is a transverse axis? The transverse axis is where your foci and your vertices are all going to lie. So that means they're all going to lie horizontally on this transverse axis. It's kind of like the major axis for an ellipse. All right, so to find our vertices, we know that the vertices are going to be a distance away, right? So we know that if a squared equals 4, then we know a equals 2, correct? So that means from the center, my vertices are now a distance away. Well, since this is a horizontal transverse axis, am I going to add or subtract a to the h coordinate or the k coordinate? The h coordinate. Because if I add it to the k, guys, I'm going to go up 2 and negative 2. But I just told you it's a horizontal transverse axis. So you got to add it left and right. So therefore, to find the vertices, I'm going to say it's going to be 1 plus or minus 2, comma, negative 2, which is going to provide me with two vertices, 3 comma negative 2 and negative 1, negative 2. Notice how my k remains exactly the same. So now I'm going to have 1, 2, 3 is one vertice, and negative 1, 3 is the other vertice. Let's put the c right here. Do you guys see how the vertices in the center all lie on that same line? That's what we call the transverse axis. And guess what? The foci lies on what line? That same line, right? But now to find the foci, that is not a distance of A, not a distance of B, that's a distance of C. Okay, so to find the foci, now we need to figure out what is that distance of C. So we know for a hyperbola, to find the hyperbola, we know that c squared equals a squared plus b squared. So hyperbola, we're trying to find out what c squared is. So we know a squared, we know b squared. So c squared equals 4 plus 1. So c squared equals 5. Therefore, c equals plus or minus the square root of 5. So now what I'm going to do, to find the foci, I'm going to do the same thing. 1 plus or minus the square root of 5, comma, negative 2. Now, I don't have a calculator with me, so we're just going to want to approximate. Well, if I know the square root of 4 is 2, and the square root of 3 is 9, the square root of 5 is going to be somewhere in between there, right? So I'll just estimate it at like 2 and something, right? Okay. So let's say, this could be approximated to 1 plus 2 point something would be like 3 point something, right? So I can add it over to 1, 2, 3, and somewhere in between there would be your foci. And then obviously if you get a calculator, you can approximate a little bit better. So now I'm going to subtract, so 1 minus 3 would be like minusing 2 point something. So now I'm going to go over 1, 2, and a little bit extra. Be somewhere right around there. So there's that foci. Okay, again, I'm just estimating the foci. So now we know that my hyperbola is going to now go towards foci, and they also asked us to find the asymptotes. So remember, the equation for the asymptotes is y equals k plus or minus. Now since this is a horizontal, we're going to have b divided by a, x minus h. All right, if it was vertical, your a and b's would be swapped, right? Yes, because there's two different equations. Okay, so now let's plug in our k, which in this case is negative 2, plus or minus b, which is 1 over 4, times x minus h, which is 1. Okay, distributive property. Y equals negative 2 plus or minus 1/4.
Isn't it
So
over 2 though?
what?
It is over
Isn't it
2.
over 2?
Oh yes, it is over 2. That's it. Thank you. I was looking at a squared. So 1/2, actually I'll just leave that. I'll just leave it in the thing. So, sorry, I'll just go through this. Okay. So what you guys can see is once you distribute that, then you can go ahead and have your two equations, which are going to produce your two asymptotes, which is going to look something like this. So you're going to have two different x-intercepts, and then you can sketch your hyperbola. Does that answer your question as far as on your foci, what it's going to look like, and go for it?
And when we're sketching the asymptotes, can we just like estimate?
Well, no, you're going to want to find what those exact equations are. So let's go ahead and distribute this then. So I have y equals, this is going to be plus or minus 1/2 x, and this is going to be minus 1/2. And then, so you can multiply, so let's just do this two different ways, okay? So you could do plus, you could have y equals plus 1/2 times x minus 1 minus 2. And you can have y equals negative 1/2 x minus 1 minus 2, right? You can do the positive and the negative. So if you did the positive, you get y equals 1/2 x minus 1/2 minus 2. And here you get y equals negative 1/2 x plus 1/2 minus 2. So in this case, you have y equals 1/2 x negative 1/2 minus 2. Would be like negative 2.5, which would be same thing as 5/2, right? So it'd be minus 5/2. And then here, you're going to have negative 3/2. So 1/2 minus 2 would be negative 1.5, which would be a negative 3/2. And you can see that both these asymptotes are negative, so that would make sense. Okay? Does that make sense how I distributed that to find the two asymptotes? So there's your two equations. Got it, Nico? Good. So, all right.
Okay.
I'm sorry. Well, the other two problems, we just found the standard form, right? So that's what I was thinking. So we got this, we completed the square, right? And so now we got our standard form. From our standard form, we were able to determine that this is going to be a horizontal, our major axis symmetry was going to be horizontal. So now, we need to determine what is the center, the vertices, and the foci,
And the eccentricity.
and eccentricity. Okay, so I can erase all this stuff, right? You guys all got this? All right down, so we're all good with this.
What is it?
That was the completed square form, which I spent the last video with. All right, so now we got all this. So now, like I said, I told you we figured out since my larger number a was under my x, I'm going to use this form. X minus 4, or I'm sorry, let's just write the standard form. X minus h squared over a squared plus y minus k squared over b squared equals 1. Right? Because my larger number is under my x, so I know that's going to be my a. That's following?
Yeah.
Why does it have to equal 1?
Completely.
Oh.
So now the next thing, the center is fairly easy. The center is just going to be the opposite, 4, 3. Is going to be your h and your k. All right? But now, to be able to determine your vertices, remember your vertices is going to be, your vertices lie on your major axis, right? Your vertices lie on your major axis. So therefore, I'm only going to be concerned about what a is. Well, I know that a squared equals 100 per that equation. So therefore, a equals 10, right? So we have some parabola that looks something like this. Centers at 4, 3, 1, 2, 3, 4, 1, 2, 3. Okay? And so we have some parabola that's going to look something like this. But each distance is 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? If you're adding 10 horizontally, then you're going to be subtracting 10 horizontally, right? Because it has to, your vertices and your center and your foci, they all lie on your major axis. So am I going to add this A, am I going to be adding it to the x coordinate or the y coordinate of your center to figure out where the two vertices are? The x coordinate, right? So to find my vertices, all I'm going to do is do plus and minus from the center. So if I add, so vertices would be 14, comma 3, and negative 6, comma 3. Does everybody understand that? Does that make sense? Because I determined that it's a horizontal. If it was vertical, we'd be plus or minus 10 to the y coordinate of the center. No? Question?
How did you get the 6 and 3?
6 and 3. Okay, all I did was I took, I just added 10. Well, here's my center, right? My center's at 4, 3, and I determined A. Remember, this distance is 2A, right? That's what we learned, right? So that means this distance from here to here is A. So if I determined A is 10, all I did was I added 10 to the center, the x coordinate of the center. So when you have 4, 3 as your center, you add 10, you get 14, 3. When I take 4, 3 and I subtract 10, I get negative 6, 3. All right? Now we need to figure out our foci. And our foci, we need to understand the relationship between our A, B, and C. Chase, you almost alive with this? Oh, it's a lot. So remember, C squared equals A squared minus B squared. That's how we're going to find the distance of C for our ellipse. So we have C squared equals A squared, which is 100, minus B squared, which is 20. So you have C squared equals 80, and square root, C equals the square root of 80. And then we go ahead and take a look at this. Let me see, all right, is there anything that we can reduce the square root of 80?
It's like 8.94.
But we want to reduce it.
And 10 is 5.
I don't know.
Anybody?
I can't do it in my head, but just go ahead and do it. It'll take me longer to do it on paper than.
6 and
4 and 10.
Yeah, I was like,
Okay,
4,
well,
8.
we know that 4 works into it.
Yeah.
So
Right.
it's 2.
So it's 4.
So how many times would 4 go in there? How many times would 4 go in there? 4 goes in there 20 times, right? So you could rewrite this as 4 times 20. So we could do 2 radical 20. But then, right? But then 4 goes in there again, right?
5 times.
So you could write 2 radical 4 times 5. So then we could do the same thing again. 2 times 2.
it's 4, 5.
Like that, which are 4, 5. Which we could have figured out would have been 16, 16 times 5 also gives you 80. But so there, now we determine that's our C. Well, remember, our C, just the same, is still on your major axis of symmetry. So there's your C, and then C, your foci. So your foci, remember, are going to be inside your vertices, between your vertices and your center. So now I'm going to do the exact same thing I did with my vertices. I'm now going to do with my foci, except my foci now is 4 times radical 5. So all we do is 4 plus 4 radical 5, comma 3, and 4 minus 4 radical 5, comma 3. Just doing like I did here. Here it was easy, I had 10. I can easily combine my terms with
How
10.
do you know where to graph that?
You know.
Well, this is going to be approximation, right? And I told you guys we didn't have to worry with your graphing. But all you had to do, you're going to have to decimal and approximate for your graph.
Well, how do you add those?
It's
Would it just
about-
be like 8 square root 5?
You'd have to convert to a, nope.
Or both?
No,
Just-
they're not
just
like
leave
terms,
it?
so you can't combine them.
Okay.
You'd have to convert to decimal and find the decimal approximation. Okay, but like,
Right.
we're not worried about finding that, we're just worried about finding the center vertices and foci for the problem.
Okay.
Okay, and then the eccentricity would be
Eccentricity, forgot about that. Eccentricity, C over A. So all you do is you figure out your C, which is 4 over radical 5, your A, which is 10, right? And then you just reduce. 2 radical 5 over 5. Yes?
What is the eccentricity?
The eccentricity is going to tell you how much your graph is kind of look like a circle or look like a really skinny oval. Okay? And really what it is it's the ratio of where your foci is between your vertices and your center. So the closer your eccentricity, is to 0, the more it's going to look like a circle. And the farther it gets out, and the larger it is, closer it is to 1, the more it looks like a oval. Okay? That's just about it. All right, so in this equation, I have y minus 4 squared divided by 9 minus x plus 3 squared divided by 25. Now, remember, ladies and gentlemen, we always have a squared minus b squared in our formula, right? So they're going to ask us to graph this. But remember, when we were talking about hyperbolas, it's always a squared minus b squared equals 1. And since this case, I have the y over my a, and the x is over my a, or my b, what type of hyperbola do I have? Do I have a hyperbola that's going to be opening transverse axis vertical, or is the transverse axis going to be horizontal? Vertical, right? So it's going to be a little bit different than what we've done before. So now I know that my transverse axis is going to be vertical. So let's go with what we know. We know that our center is obviously going to be h comma k, right? If it was for horizontal, the x would be over the a. The vertical is when the y is over the a. Got it? OK. The vertical, this would be vertical. All right, sorry, it is vertical. It would be horizontal if the x and y's were switched. Whenever you have the, remember, it's always a squared minus b squared for a hyperbola, right? It's not like an ellipse. Yeah. It's all, remember, everybody gets it confused with an ellipse saying, oh, that's a and that's b. No, it's always a squared minus b squared. OK? So we have centers hk. So in this case, it's -3. -3 comma 4. Right? You got to make sure you just remember where the h is and where the k is, right?
Why did you put -3?
Because remember, it's opposite. It's x opposite of h. This says x opposite of h. So you got to say, what is the opposite of your 3, which would be -3.
When did you say it was opposite? Or
Guys, we've been using this rule since the beginning. This formula, the center, look at, the center is h comma k. OK? Now watch. Watch what I'm doing. Pay attention, please. This y minus k. What is the value of k in the parentheses? Positive. So all I'm saying is y minus k. K is k. So when I say what is k, if I say h comma k, so if I do y minus 3, that means k is equal to 3. Do you guys see that? It's not -3, it's 3.
okay, so then why is it positive?
All right, so let's look at it this way. So positive y minus a -3, right? So that looks like y plus 3 though, right? But that's why we say, so when I say y plus 3, that's why it's -3, right? Because the actual value for your k is -3. If you just want to go through the simple terms, just remember that it's just always opposite. If here's your formula, your center is h comma k, so it's always going to be the opposite terms. All right? All right, so we have our center is -3 comma 4. Now we know our a squared equals 9, and b squared equals 25. Wendy, I shouldn't be able to hear that.
A squared is 81.
A squared is 9, right? Your a squared's right up there. So now, if I know a squared is 9, then I know a equals 3, and b equals 5. So remember, we're going to be trying graphing this, right? Yes? OK. So to finish up graphing this, let's just plot what we know right now, and then we'll get to the rest of it. So the first thing I can do is plot the center, which is negative 3, 4. So I go over negative 3, 1, 2, 3, up 4. 1, 2, 3, 4. That's my center. Now, we know our A. Now, ladies and gentlemen, we determine, is this going to be horizontal or vertical?
Vertical.
Vertical, right? So my vertices, are they going to be above and below my center or to the left and right? Above and below. So we know my A is 3, so I'm just going to go up 3 units. 1, 2, 3. And then I need to go down 3 units. 1, 2, 3. Does that make sense? Those are my 2 vertices. The distance, remember the distance from the center to the vertice is 3, or is A. Well, A is 3, so I just go up and down 3. Now, the next thing is, though, we need to find the focus. We're not really concerned with B. B tells us our covertices, which aren't a part of our graph. So we need to figure out what C is. So remember, C squared equals A squared plus B squared. That's for a hyperbola. So C squared, we don't know what it is, equals A squared, which is 9, plus B squared, which is 25. So C squared equals the square, or equals 34. Square root, C equals approximately, what, 5 points? Square root of 34 approximately is 5 points, or 5.78. Square root of 34. 5.8. So we're just going to approximate 5.8 because I want to sketch the graph. So instead of my center, now I'm going to go up and down 5.8, right? Because remember, the foci, then the vertices in the center are all on the same transverse axis. So now I go up roughly 5.8. 1, 2, 3, 4, 5.8. Then I go down 5.8. So 1, 2, 3, 4, 5. So 0.8 is roughly somewhere around there. All right? So now I know my graph is going to open up and it's going to open down because my points all lie on this transverse axis. However, remember we have asymptotes, right? Right? So a hyperbola has our asymptotes. So remember, since we have a vertical, we know that the equation for asymptotes of a vertical equation is y equals k plus or minus a over b times x minus h. For a horizontal, it's b over a. For a vertical, it's a over b. All right? So therefore, you have y equals k, which in this case is 4, plus or minus our a, which is 3, over our b, times our x, minus our h, which is negative 3. So it'd be plus 3. Are you serious? I don't want to graph these. All right. So what I'm going to do is I'm going to do these separately. Y equals 4 plus or minus. Or I'm sorry, let's do these separately. Plus 3/5 x plus 9 over 5. And then let's do y equals 4 minus 3/5 x. Excuse me. Hold on, we're not done yet. So you need to graph these 2 asymptotes, all right? So the last thing, guys, if you get those to be the same, you're going to have to graph the line y equals 3/5 x. Get these to be common denominators, which would be plus 29 over 5, which you're going to have to approximate. And then here, you're going to have to get these to be common denominators, 20, so that's going to be 11. So y equals 3/5 x minus 11 over 5. And then I'm just going to kind of shorten this up because I know we are running out of time. Just to let you guys know, your asymptotes are going to look something like this. They're where your graph is going to approach. So what you can see is the shape of the graph is going to be something like this. That's my transverse axis. That's not really part of the graph. I just graphed it so you guys could see that's where everything lies. So you have your focus, your vertice, your asymptotes, your center, your vertice, and your foci. All right? So the first thing I want to do in this case is, again, write this in our conic section form. Right? So the first thing I'm going to do is divide by 4 on both sides. So therefore, I have x squared over 4 minus y plus 1 squared over 1 equals 1. Right? You don't have to write it over 1, but I think it's always helpful to kind of have that 1 there. Right? You don't have to write it there, but it's helpful to kind of know because this is a hyperbola, right? So we remember hyperbola is a squared minus b squared. So we know my a squared is going to be 4. Therefore, a is equal to 2. B squared is equal to 1. Therefore, b is equal to 1. And c squared is a squared plus b squared, which is 5. So therefore, c equals the square root of 5. Did you guys see how quickly I was able to do all of that? Right? And you guys should be able to do the same if it's an ellipse or a hyperbola. The next thing is we need to identify the center. So remember that the h is always with x. So therefore, I do not subtract anything from x. So therefore, my h is 0. And then my k is always with my y. So remember, it's y minus k. So therefore, y minus what would be positive 1? Y minus negative 1. So my center is going to be at 0, negative 1. All right? So I'm going to sketch that information. 0, negative 1. And I'm going to label it. Now, since my a squared is under my x, since my a is under my x, should my transverse axis be horizontal or should it be vertical? Horizontal. So you don't have to do this, but I like to do it to avoid making mistakes. I just sketch a nice little axis and I just label it with a T. And that just triggers my brain to say, OK, the transverse axis is horizontal. What lies on the transverse axis? So the transverse axis is going to lie horizontal. It's going to lie on the vertices as well as the foci. So what we're going to do in that case is we need to find our a, which is 2. So that means it's going to be going left and right. So let's go to the right 2 and to the left 2. And we'll label those our 2 vertices. Okay? And technically, guys, what did we really do? We just took 0 and added 2 and subtracted 2, right? So I can say my vertices are going to be plus or minus 2, negative 1. Really went 2 to the right, negative 1, and 2 to the left, negative 1. Right? My foci also lie on my transverse axis. And that's a distance of c. Now, this kind of confuses people again. When we have square roots, we don't know. And I'm sure with a calculator, you guys would probably type in square root of 5. But in reality, guys, by the time it even takes you to touch your calculator, you know the square root of 4 is 2, and the square root of 9 is 3. So would you agree with me the square root of 5 is somewhere in between 2 and 3? And you can probably figure that out quicker than it is to grab your calculator and turn it on. And that's all you need to do is just estimate where it should be. OK, that's it. But that is basically saying plus or minus square root of 5, negative 1. OK. And then last but not least is our asymptotes. So the equations of the asymptotes are over there. But I'm going to show you, I'll show you how to graph them in a second. So this is a horizontal transverse axis. So by the equation of my asymptotes, the asymptote equation looks like this. Y equals plus or minus b over a times x minus h plus k. Now, do we have a, b, h, and k? Yeah. So y equals plus or minus b over a, which is 1/2. X plus k, which is minus 1. So guys, is that really that hard of an equation to graph? Oh, from your Algebra 1 days, you should be able to do that, right? But it's OK. I'm not even going to expect you guys to graph that. The way that I would do it is, again, find my covertices, which is up 1 and down 1. I would create a box. Oh, there's my And then by creating my box, I can draw my asymptotes, I think, with better ease. Okay? I'm not going to be anything exact. I will say that I will want you to have the equation written down. And then graphing can just be a rough sketch. Doesn't need to be anything perfect. So, ladies and gentlemen, we have a parabola. Or I'm sorry, not a parabola. We have an equation. We want to write it into our standard form. And then we want to plot the asymptotes and make a little sketch of the graph. How's that sound? That sounds terrible. Okay. So the first thing is, again, if we know our definition of our parabolas, we need to first, before we can even determine if it's going to be horizontal or vertical, we need to at least be able to see what the graph is going to look like. So first thing we do is I'm going to combine my 4x squared plus 8x minus 3y squared equals a negative 16. So I put the constant on the other side, and I arrange my x's and my y's. And I do that because now I want to make sure that I can combine them, because I forgot to go over this. Let's go over the formulas, right, that we're trying to figure out. Okay, this one is x minus, this one would be y minus k. Okay, so we have our two formulas, and what we need to do is we need to make sure we can write this in that formula, right? So first thing I need to do is now I'm going to have to complete the square. Before I complete the square of the x, I need to make sure I factor out a 4. I can't complete the square with my negative 3, but that's fine. That just means that my k is going to be 0, right? Now I complete the square over here, so I have 8. Got to factor out a 4, so that's a 2. So I have 2 divided by 2 squared, which equals 1. So I have 4 times x squared plus 2x plus 1 minus 3y squared equals negative 16. However, ladies and gentlemen, notice that I'm not adding a 1. I'm adding a 1 that's being multiplied by a 4. So therefore, I'm going to have to add a 4 over here as well. So therefore, now I simplify, or I factor this down to its perfect square, or binomial squared. So it's x plus 1 squared minus 3y squared equals negative 12. Now, again, remember, both of our formulas equal 1, right? Both those formulas equal 1. So let's divide by negative 12. And we'll do this by both terms. Therefore, by simplifying this, I now have a negative 3 times x plus 1 squared plus y squared over 4. I'm sorry, that's a 3 on the bottom, right?
Well, so you make the top negative, not the bottom?
It doesn't matter. Negative 4 divided by 2 is the
Why are you
same.
adding? I thought it was multiplying. Because.
The negatives divided by another negative makes a positive, right?
True.
So now, you're right though, this needs to be a subtraction problem, right? So rather than saying a negative number plus a positive, I can rewrite this as y squared over 4 minus x plus 1 squared over 3 equals 1. So you're right. Right? You want to write it in that format, because now when you have it as a subtraction, you know now that a squared equals 4 and b squared equals 3. Right?
How do you, oh, okay.
Because it's always a squared minus b squared. For our hyperbola, a squared minus b squared. Huh?
A is always the larger one.
No, not necessarily.
Oh, God.
It's just always in the formula, a squared minus b squared. That's the formula that we're always going to have in this form.
So in hyperbolas, it's not gonna matter whether it's bigger or not.
You're not always going to have a larger or smaller.
But I thought you said that the A is.
On your ellipse, on the ellipses, that's the way that you're always going to have it. Okay?
So how do you know in here?
You just write it as a subtraction, one minus the other, and then whatever that is, whatever you're subtracted from, that's your a minus your b.
So it can be negative. It can be 4 minus 5.
Yeah, that was our last example, right? So now let's go and take a look at our h and our k. So if we know our h is now represents our, sorry, let's just do our center. So now I can say the center is going to be negative 1 comma 0. Yes? Yes? No? Maybe so? Okay. So, so ladies and gentlemen, if we have our 4 and our y, if our a squared is under our y, now this means we're going to have a vertical one, right? So, we know our center is at negative 1, 0. Okay? The vertices are going to be plus or minus 4. So therefore, if a squared equals 4, we know that a equals 2. So to find the vertices, ladies and gentlemen, are your vertices...
Pardon the interruption. Please turn your TV sets to channel 6 for the Mustang News.
Since this has a vertical transverse axis, our vertices are going to be on the transverse axis as well. So our vertices are going to be negative 1 comma plus or minus 2, right? Which will be negative 1 comma negative 2 and negative 1 comma 2.
Wait, did we ever get like formulas to how to figure out the vertices, or how do you figure out the vertices?
It's the same distance, it's a.
Okay.
So it's the same thing as an ellipse, it's just your definition of a. The only thing you need to know is it's on the same as your transverse axis. Remember ellipses, they were all on the same major axis? Well, now they're on the same what we call a transverse axis. So the h is not changing in this case because you have a vertical transverse axis. The same thing now goes with our foci. Now we need to determine what the foci is. And remember the relationship we have for hyperbolas. Obviously, I think that was a bad reason for you to come back in class at this point in time. Because remember the definition for the foci that we had was c squared equals a squared plus b squared. Well, we have a squared is 4 plus b squared, which is 3. Right?
You just need c squared though, not c, right?
Sorry?
Do you only need c squared, not c?
No, we actually need to figure out what c is. Because c is the difference, c is the distance from your center to your foci. So c is the square root of 7, so our foci are going to be negative 1 comma plus or minus the square root of 7, which is negative 1 plus, or sorry, negative 1 comma 0. Sorry, 0 plus or minus 2, 0 plus or minus square root of 7. So,
Does that
plus
matter? Yeah, why is it?
Because, yeah, of course it matters. That's a huge mistake. Guys, you're taking your center and adding the vertice to your k, to the k coordinate of your vertice. This one just happened to be c, so it didn't matter.
Yeah, but why, do you have to put 0 plus?
No, you don't have to, and that's why I got lazy and I didn't write it. But you need to understand you're adding it to the k form of your center. You just need to make sure you understand that. In this case, yeah, you're going to have square root of 7, and in this case you have negative 1 minus the square root of 7. Well, guys, you can write those in your decimal form. Square root of 7 is roughly 2.645751.3. I'm sorry, say that again.
Are you allowed to put negative square root of 7?
Because why don't you not take the square root of negative 7? But yeah, leave it in that exact answer. So your foci are going to be somewhere right around here. Alright. Now last thing, ladies and gentlemen, remember they're in between. They're between the center and the vertices, are your foci. Now, that's an approximate value. The last thing, ladies and gentlemen, we're trying to do is find our asymptotes. So remember, for a vertical asymptote, we have y equals k plus or minus a divided by b times x minus h. So all we're going to do to find our asymptotes is plug in these values. So we have our k, which is 0, plus or minus a over b. So our a is 2, and our b is square root of 3. h, which is -1.
You can just leave it as -1. Oh.
So then when I distribute that through, you're going to have that line. Oh, I'm sorry, and it's plus or minus, sorry.
Do we need to do the 3?
We will learn how to graph them, but we'll practice that next class break, just so you guys understand how to find the asymptote, okay? So again, just kind of working it in a step process. The first thing you're going to want to do, Josh, is group the x's and the y's. So I group the x's. And then I put the constant on the other side. All right? So now the next thing I need to do is complete the square. I need to create two perfect square trinomials that I can rewrite as binomial squared. So I need to complete the square. Before I can go ahead and do that, I need to make sure I factor out my constants in front to make sure my x squareds are equal, or my coefficient of x squared equals 1. So the first term, I'll factor out a 4. And then here I'll factor out a -9. Does everybody follow me right there? Okay. Now, this is much better than your homework quiz. Now I just need to create my perfect square trinomials. I need to take b divided by 2 and square it. So I take -4 divided by 2 and square it, which equals -4 divided by 2, which is -2, which equals 4. And then over here, I take 2 divided by 2 and square it. So, and that equals 1. So now remember, what do we do with those numbers? We plug them into both of our parentheses to make our constant for our perfect square trinomial, as well as add them to the other side. But as I've mentioned before, the most common mistake that students make is that they forget to not only add them to the other side, that's a squared, but they forget to add them correctly to the other side. So since I took this 4, I added it inside the parentheses. That means I need to add 4 over here. But notice this 4 on the left side is being multiplied by 4. So the 4 on the right side that I add also has to be multiplied by 4. Same thing with the 1. I'm adding 1 on the left side. I need to add a 1 on the right side. But that 1 is being multiplied by -9. So this one needs to be multiplied by -9 as well. All right? So now what I'll be able to do is now I can rewrite my binomial squares as perfect square trinomials. If you guys remember, it's just b divided by 2, x plus or minus b divided by 2. But hopefully you guys recognize these two perfect square trinomials as x minus 2 squared minus 9 times y plus 1 squared equals 4 times 4 is 16. So if you guys add all that up, you'll get 36. Now, remember, our equation for a hyperbola or an ellipse is it's equal to 1. Now, this is going to be a hyperbola because I noticed I'm subtracting between my two terms. But either way, I'll divide everything by 36. So when dividing by everything by 36, this reduces to 1/9. This reduces down to 1/4. That goes down to as 1. Okay? So therefore, ladies and gentlemen, now what I have is x minus 2 squared over 3 minus y plus 1 squared over 4 equals 1. Does everybody see that? Anybody have any questions on that? We're not done yet, because what did the question actually ask? So it's asking us for the type of graph, the orientation, and the center. Well, the center, actually what I'm going to do is we're going to find all the points, because I know in your test that's what you guys have to do. So the center is 2, -1. Now this is also, since I see the subtraction, I know it's a hyperbola. But my main question is does this hyperbola have a major axis, or I'm sorry, a transverse axis that is horizontal or vertical? Aaron. Okay, that's why we're looking over here, so I'll go over to Charlie. Charlie, do you know, is this a horizontal or a vertical transverse axis? Incorrect. It is a horizontal. The reason why you did, it was not too bad. The reason why it's a horizontal is because remember it's always a squared minus b squared for hyperbolas, right? Always. So since my x is over my a, it's horizontal transverse axis. All right, and that's very important because if it's a horizontal transverse axis, ladies and gentlemen, that means my graph, let's pretend it looks like this. If it's horizontal, then we know that the vertices and the foci and the center all lie horizontally. Therefore, if I'm asking you to find the foci and the vertices, are you going to be adding, you're going to be adding left or right, right? Not up or down. So what am I going to add to on my center, the x coordinates or the y coordinates, Lucas? X coordinates, because that's going to go left or right. So since we already know what a and b are, we can say that a squared equals 3. So therefore, a equals the square root of 3. B squared equals 4. So therefore, b equals 2. And then to find c, remember the formula is c squared equals a squared plus b squared. So c squared equals, what, 7? Square root, c equals the square root of 7, which is 2.64575, 13. But we'll just leave it as that. All right. So just in case you need to do this for your test, which you guys do need to know, let's go ahead and determine what the center, the vertices, and the foci are going to be. We know the center is 2, -1. The vertices are at the center, but they're just the a distance away. But remember, since we're going left to right, I'm going to add and subtract them to my center, or my x coordinate. So it's going to be 2 plus or minus 3, -1. Please simplify this if you can. So 2 plus 3, it's going to be 5, -1, or -1, -1. Then the foci. The foci have the distance of c. Since we figured out the value of c, which is the square root of 7, we're going to say 2 plus or minus the square root of 7 minus 1. You don't need to break that one apart. I'll accept it like that since it cannot be really simplified. But do you guys notice how the y coordinates all the same for the center, the vertices, and the foci? Because they all lie on that horizontal axis. That's what's most important about that for you guys to understand that. That's all the question was asking. I went a little above and beyond for you because I know your test will be something similar to what I just did. Yes? Exact same thing, ladies and gentlemen. We've talked about, we have 2 different examples, right? We have one where the transverse axis is going to be horizontal, and we're going to have an example where our transverse axis for our hyperbola is going to be vertical. So we want to make sure that we plot our points first, so therefore we can determine, are we going to be dealing with an equation? Are we going to be writing an equation that's going to have a hyperbola that is going to be with the transverse axis, horizontal or vertical? So let's just plot it real quick, just to kind of take a look. So as I plot my points, -1, 2, 5, 2, and then my vertices are at 0, 2, and at 4, 2. So I have my vertices and my foci, or foci. Now, ladies and gentlemen, is this going to produce a hyperbola that's going to have a transverse axis horizontal or vertical?
I'm guessing it's
Close. Remember, your foci and your vertices are all going to lie on the transverse axis. So therefore, they're all going to lie on this axis right here. So, are we going to have a transverse axis that's going to be horizontal or vertical?
Horizontal.
Horizontal. Do you see now how it makes more sense when I put them on a horizontal line?
Oh, okay, got confused.
So,
How?
now we need to write out our equation because that's what we want to figure out. So our equation that we're going to use, since now we know it's going to be horizontal. Remember, we always have for hyperbolas a squared minus b squared.
Is this at 0, 0? Sorry.
No, we'll talk about that in a second. So therefore, I'm going to have
Oh,
x
yeah.
minus h squared minus y minus k. Okay. So therefore, for us to figure out this equation, we need to know the center, we need to know a, we need to know b, right? So remember that the vertices are the exact distance from our center point. So I have vertices at 0 or at -1, 2, and at 5, 2. So how far is that distance? 1, 2, 3, 4, 5, 6.
Oh.
Yeah, 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5, 6. Right. So you could say 2a equals 6, right? So therefore, my a equals 3. That means the distance from my center to my vertices is going to be 3. So therefore, if I just travel back 3, I can figure out where my center is going to be, which is
2.
Where's my 2 vertices? 1, 2. Oh, I was doing foci.
5 minus 3. What are you doing?
I was doing my foci.
I'm so good.
That's because I was doing 2c. The distance between your 2 foci was 2c, which is c equals 3. My apologies. If I do a, the distance between my 2 vertices, which is 0, 2, and 4, 0,
4.
was 4. Thank you. So you can say 2a is equal to 4, divide by 2, a equals 2. Now again, let's go in 2 units from our a, or from our vertices. 1, 2. Let's make this a different
2,
time.
2 is the center.
And now let's go 3 units from your foci. 1, 2, 3. Oh, look it. My center is going to be at 2, 1. Yes?
How did you find the center?
Remember, the center is exactly in between your 2 vertices and your foci.
No.
Right?
It's 2, 2. Yeah.
Yes, 2, 2. Right? It's right in the middle, between the 2 vertices and the 2 foci. Right? So what I did is I pretty much just found the distance between my 2 foci and divided it by 2. I found the distance between my 2 vertices and then divided it by 2. Okay? Because it's right in the middle. The center is right in the middle. It's equal distance to both vertices and both foci. So you just need to find that middle, which is
C come into place?
C is the distance from the center to the foci. C is this distance from the center to your foci. A is the distance from your center to your vertice. So now we know our center is 2, 2, right? Very, very good. Now let's go and take a look at, so if we know the center is 2, 2, the next thing is we need to figure out what our a is. Well, we talked about a squared. We know a is 2, so therefore a squared is going to equal 4. Now, do we know what b squared is? No. But do we know what c squared is? C squared is now going to be the distance, remember here, so c is 3, so c squared equals 9. Now, why is it so important for us to be able to figure out what c and a are? Because now we can figure out what b is, right?
B is bigger than A, though. When you figure it out.
Okay, so let's go and take a look at it. So remember, in this one we're going to have c squared equals a squared plus b squared. Right? So, but remember now, it's a little bit different than what we were dealing with on the last one. Your b is going to represent different values. Because remember, now we have this inverted, right? It's not opening like an ellipse. Now it's inverted going back the other way.
Yeah.
So therefore, remember, look at a is smaller. A is small. Remember, on an ellipse, a was your larger, right? Because a was outside your foci. Now it's inside the foci, right? So here we're going to have c squared equals a squared minus b squared. So we have 9 equals 4 plus b squared. Minus 4, you get the square root of 5 equals b squared. So therefore,
Isn't it just square root of? Why did you?
oh, sorry, 5. Sorry. Thank you. I was just going to the next step. So now, just to find my standard form, I plug in my center, which will be x minus 2 squared minus y minus 2 squared divided by a squared, which is 4, minus b squared, which is not 9, 5.
But I thought you said A squared was always bigger, even in this, and that's why you said.
I didn't say anything with this. I just said we were always going to be subtracting your a minus your b to keep it constant. I didn't say it's always going to have to be bigger. I just said to keep things consistent, because remember, if you don't have it consistent, if you're doing something bigger, then yeah, you wouldn't have the same thing.
Okay.
in this example, guys, first thing we want to do is plot the points. So we have 2 points, our vertices. So 1, 2, up 2, 3, and over 2, down 3. And then also positive 0.05. 1, 2, 3, 4, 5. But here's our vertice, and here's our vertices. So it's important to understand that our vertices lie on our transverse axis. So our transverse axis, since our transverse axis is vertical, we know that we're going to use the equation where a squared is under the y, correct? We also know that between our two vertices is the center. So the midpoint of these 2 points is going to be our center, which is at 3, 0. So right now, at this point, we know that we have y minus 0 squared over a squared, because a squared needs to be under the y because of the vertical transverse axis, minus x minus 3 squared over b squared equals 1. 2, 0. That is at 2, 0. Good catch. Is everybody OK with my equation up to this point?
Yes.
Now, the problem is I have no idea what a squared is b squared is. But I do actually know what a squared is b squared. It's not on my phone. It's actually not on my phone. I swear. If you're looking at your phone, it's not on your phone. A represents the distance from your center to your vertice. 1, 2, 3. Right? Or 1, 2. It doesn't matter which direction. It's the distance. So a is equal to 3. Thankfully, I plotted this. So therefore, I can visually see that. A is equal to 3. Therefore, I can just rewrite this as y squared over 9 minus x minus 2 squared over b squared equals 1. Now, the problem is I have a y, an x, and a b, right, as unknowns. Well, I need to figure out what b is. I don't have enough information right now to figure out b. But what other piece of information was I given? What is that 0, 5? What does that represent? That represents the coordinate points on your hyperbola. So therefore, we can replace color. Oh, this is the bad blue. Ah, see that? We can replace the y with a 5 and the x with a 0. Now, let's mathematically go ahead and solve for b squared. So 5 squared is 25 over 9. 0 minus 2 is negative 2. Negative 2 squared is 4. Now, this doesn't look like it's going to be very fun, is it? So let's rewrite our 1 as 9 over 9. I kind of know what to expect, so that's why I'm doing this. And hopefully you guys realize that 9 over 9 is the same thing as 1. The reason why I'm doing that is I know to solve for b squared, I need to subtract a 25 over 9 on both sides. So by rewriting my 1 as a denominator with 9, this is a little bit easier now to subtract, right? Now, I did run out of space, so I'm going to do what I told you not to do and do a nice little line over here and say, I'm going to continue my work right there. Do I like have any good markers left? So therefore, I'm left with a negative 4 over b squared equals 9 minus 25 is a negative 16 over 9. Now, you could multiply or think about like the cross product. Either way, you're going to get negative 36 equals a negative 16b squared. And when you solve for b squared, you're going to get a positive 36 over 16, which simplifies down to a, 9/4. Now, again, guys, to write my equation, I'm just concerned about what b squared is. So I'm going to rewrite the equation over here, because I think I have enough space. So therefore, this is really y squared over 9. We already knew that. Minus x minus 2 squared over b squared, which is 9/4 equals 1. Now, that is correct, but that wouldn't be considered simplifying. Dividing by a fraction is the same thing as multiplying by the reciprocal. So a more simplified version, which you would see on a multiple choice test, would look like this. Or could you just multiply everything by 9 as well? Or you could also write it like that. They're kind of like more simplified as you kind of go down. They're all correct. Just one's kind of a little bit more simplified from there. So if you get a fraction in your denominator, don't freak out. It doesn't mean you did something completely wrong. It's possible to get some fractions. OK? So last one, they give us the center, which is 1, 4. So that's my HK. Now this one can kind of be a little confusing as well. They give me by value c, but then they give me eccentricity. Now eccentricity isn't on your notes for the I didn't write it down, but if you guys remember from ellipse, eccentricity is c over a. Yes, it was on your notes from last class. So eccentricity is c equals a. So they're saying the eccentricity is 2, but they're saying that 6 is c. So basically your eccentricity, which is 2, is equal to c, which is 6 over a. So therefore a has to equal what? 3. So just using a little bit of problem solving there to figure out a is equal to 3. Now we need to figure out b, and we can do that because we have a and we have c, right? Yes?
When it says horizontal focal axis, is it just telling us that?
So remember another thing, like I talked about it last notes, the focal axis lies on the transverse axis, but it's between the two foci, right? So yeah, I mean, it's not something I want you guys to focus on. That was just the problem. It was good for me to like remind you. Focal axis is the same as or it lies on the transverse axis. So therefore, a squared is equal to 9. If c is equal to 6, then c squared is equal to 36. So let's do a squared plus b squared equals c squared. So that's 9 plus b squared equals 36. So b squared equals 27. It says it's a horizontal focal axis. So again, this is the exact same formula. We're going to keep on doing this. I should have changed that up. Sorry about that. So this will be x minus 1 squared over my a squared, which is 9, minus y minus 4 squared over 27. There you go. Sorry, I should have picked a vertical transverse axis for you guys, at least on one of these, but I didn't catch it. OK, so what we're going to deal with on this one is, again, ladies and gentlemen, please remember your first step is to draw what you have been given. Now, I'm not going to be too worried about what the asymptotes look like. We'll get to that in a second. But all they're asking us to do is write the equation. So yeah, the asymptotes are going to help us out. But what I mainly like you guys to focus on is graphing the vertices. Because if we know the vertices, if the two vertices lie on a horizontal line, then we know we have a horizontal transverse axis, right? If the vertices are like this, we have a vertical transverse axis. And that's going to tell us which equation to use. So I'm going to plot the information I'm given. So 9, 0, negative 9, 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a vertice and that's a vertice. So since I have vertices that are horizontally away from each other, I know I'm going to have a horizontal axis of symmetry. So therefore, my formula is going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. All right? Now, they gave me the asymptotes, right? I also need to remember what is the formula for a horizontal hyperbola for the asymptotes. So if you guys remember, I gave you the formula for asymptotes for a horizontal hyperbola, and then I gave you the formula for vertical hyperbola, which is going to be y equals k plus or minus b over a times x minus h. For a horizontal hyperbola, that is the formula for the asymptote. Formula. OK. So now let's go and take a look at what we have. Again, since we know our two vertices, can we figure out what our center is? Yeah, our center is 0, 0, right? So I'll say, all right, center, 0, 0. Then remember, the distance from the vertice to the center is your a, right? So we can say a equals 9. So since a equals 9, that means a squared equals 81.
81.
All right, now let's look at what our two asymptotes are. Notice how the formula is b over a, right? So you notice you have a is your 9. So therefore, my b has to be what? 7. So therefore, if b equals 7, then b squared equals 49. So now, ladies and gentlemen, we know A, we know B, and we know the center. Can we now write the equation?
We can.
Yeah, absolutely. So can I not write x minus 0 squared this time and just write x squared? Will that make sense?
Yeah.
Because I just did it last time? Maybe. So it's going to be x squared over a squared, which is 81, minus b squared, which or y minus k squared. No, I'm sorry, just y squared. Now I'm messing myself up. Over y squared over 49 equals 1.
So the x always goes over a, right?
When it's a horizontal axis. See, this graph is going to look like this, right? But if the graph was opening up and down, then the x would be over these would be swapped.
How do you get 7?
Because the asymptote equation, and it's 7 over 9, and b is 7.
So it's b over a, and we know a is 9, so therefore b is 7.
It's not
Okay.
9
In this example, the asymptote is y equals 2x, and my covertices are plus or minus 8. So again, guys, the first thing I ask you to do is not to be looking at your phone, but to actually plot the information using markers that actually work. So up here I have plus negative 8, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. Now again, guys, these are my covertices, not my vertices. But from here, I can develop a lot of information. First of all, I understand that just like for the ellipse, the hyperbola is no different. The center is the midpoint of my two covertices. So right here, I can identify that the center is going to be at 0, 0. Do you guys agree? Also, I know that the transverse axis is where the vertices and the foci are. So if my covertices are left and right, that means my vertices have to be up or down. Correct? That means my transverse axis is going to be vertical. That also means my vertices are going to be up and down. That means they're vertical. So my equation is going to be in, I'm going to have my a squared is going to be under my y. Now, so let's write it like this. So we have, oh, and then the other thing is, the distance from the center to your covertice is 8, but it's also equal to b. So now we know the value of b. So let's go and write in the information that we have here, so at least so far. So we know we have y squared, because it's minus 0, over a squared, which we don't know right now. And that's going to be minus x squared over 64. So we got to figure out a squared. So we look at what other piece of information we've given. Well, we've been given the asymptote. Now, remember, for a vertical transverse axis, the asymptote is going to be plus or minus vertical. That's going to be a over b. No. Vertical. Isn't this vertical? Yeah. So vertical is going to be a over b, right? Yeah. So we know, we didn't know a, but we know b. So a over b is going to equal to 2. Right? So therefore, a is going to equal 16. So then 16 squared is going to be 16 times 16, which is 256? OK, there you go. Yes? No? OK. All right, so we have the foci at 0, plus or minus 8. And we have an asymptote of y equals 4x. All right. So first of all, guys, the main important thing is we need to determine, is this going to be a vertical or a horizontal? Since I'm adding, my foci is going to be plus or minus on the k. We know that it's going to be a vertical. Good. However, let's just go and sketch it real quick. So it says plus or minus 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, the one thing we notice, ladies and gentlemen, is since it is on that y-axis, we also know what else. Oh, I'm sorry. Crap. That's just the foci, right?
Yeah.
Not the vertices. We don't know where the vertices are at. So remember though that my foci, my vertices, and my center all have to lie on this y-axis, because that's now called my transverse axis. So I know that now C equals 8, right? And I could say that my center is at 0, 0. All right? But to be able to figure out the rest of this problem, to be able to write the equation, I need to figure out what A and B are, correct? So we go back and we look at our asymptote, which in this case, since it is vertical, do I have that written down? Yeah, vertical. So the vertical, we have y equals k plus or minus a over b times x minus h. Right? And which one was this problem? Was this I was doing again? 25. Yeah, okay. So when we have this, well, the only thing they tell us is y equals plus or minus 4x. So what is 4 going to represent? What does 4 represent?
Oh, A over B.
A over b. So we could say 4 equals a over b. Sorry, 8 times a over b. Does that make sense? Yes? Well, that's not really going to help us because we want to figure out what a and b are, right? But I can multiply by b on both sides. And I can say a equals 4b. Not an exact value, but something we can get into there. Now, why would that become important? Well, ladies and gentlemen, the only last piece of information I know is that c squared equals a squared plus b squared, right? So c squared is 64. That's going to be 8 squared equals, now, what can I plug in for a squared? I don't have no relationship for a. The only thing I know for a is a equals 4b.
4B squared.
So I could say 4b squared, and then I don't know what b squared is, so I'll just leave it like that. So therefore, this gives me 64 equals 16b squared plus b squared. This is helpful, right? I don't want to solve for b for a value of a, but now since I both have a b squared, I can say 64 equals 17b squared divided by 17. We could say b squared equals 64 divided by 17. Whew. Okay, so now I know what b squared is and I know what c squared is. So let's go back to it. So c squared equals a squared plus b squared. 8 squared is still 64 equals a squared plus now 64 over 17. So now to solve for a, I subtract 64 over 17. So I have 64 minus, what am I doing? What shows this? C squared is 64, and this is 6. It is 64 over 17? Okay. Equals 64 over 17. Yes? But before I can do that, I need to get them to be the common denominators. So right now, this is over 1. So I need to get them to be common denominators, so I'm going to multiply by 17 over 17. So I have 17 times 64 equals 1,088 over 17 minus 64 over 17. So therefore, I get 1,024 over 17 equals a squared. All right, so our final answer here. Now what we're going to have is, so now we know what b squared is, and we know what a squared is. And we know our center is 0, 0, so that's not bad. And we know it's a vertical, so therefore our formula is going to be y squared over a squared minus x squared over b squared equals 1, right? I don't need to do the x and the h and the k because I know the center's at 0, 0. So therefore I have y squared over a squared, which is 1,024 over 17 minus x squared over b squared, which is 64 over 17 equals 1. And ladies and gentlemen, we don't want to write a fraction divided by another fraction, so I'll just invert this as the multiplication. So my final answer is going to be 17y squared over 1024 minus 17x squared over 64 equals 1. And there you go.
Oh, this was all just one problem?
So that's what you had to do if you don't know A or B?
Well, yeah, because you know the relationship with A and B. So, yeah, that's what you guys have to do. Okay,